In this demo, we'll work with GPT models. Okay, to get started, I've opened my Microsoft Edge browser, and I've navigated to chat.openai.com, which redirects me to chat.openai.com/auth/login. Now, from here, if I don't have an account, I can select Sign Up. That takes me to the Create Your Account page, where I can specify an email address. I can also log in from here if I already have an account, or I can use either Google, Microsoft account, or my Apple account to sign up. Okay, so I already have an account, and I'm signed in with my Chrome browser. So let's go over to the Chrome browser by selecting the Chrome browser icon on the taskbar. Okay, and on the first tab, I've signed into chat.openai.com. Now, there are a couple of GPT models listed. I'm not signed up to a paid account with this account, so I have access to GPT 3.5 only. But that's pretty significant. Now, at this point, it's important to maybe discuss a couple of options on how to interact with ChatGPT. So there are several techniques for crafting effective prompts. Common techniques include defining the output format, providing context or examples, and asking the AI to think in step-by-step or to debate the pros and cons of some subject. So in the Send a Message field, I'll type, "Debate the pros and cons of the fusion of generative AI and cybersecurity." To send the message, I can either press Enter or I can select the Send icon. So I'll just press Enter. Then now ChatGPT is generating the response based on my request. Okay, so that's how ChatGPT works in the Chat web-based application. On my second tab, so let's go over to the second tab, I'm open to platform.openai.com. Now here, I'm also signed in with the same account, and I have access to the full slate of documentation here. So if I select the Documentation tab, I have all the documentation for the OpenAI platform. I also have an Examples tab where there are numerous examples to play with. I also have a Playground tab where I can experiment with the platform. Let's select the API Reference tab. So this is the full API reference. And this is the other way that I'm going to be working with the GPT models. I'm going to be writing some Python code later in this path. So I'll need to install the OpenAI bindings. And to do that, I'll use the Python pip package manager and use pip install OpenAI to install the OpenAI bindings. Now, I'll scroll down and under Authentication, I'll select the API Keys link. Okay, and that brings me over to the API Keys page. Now, it shows that I have an API key, but if I want to create a new one, I just select Create a New Secret Key. I can give it a meaningful name. I'll just leave the default for my demo, and then select Create Secret Key. That provides me with the secret key. Now I can copy that and save it somewhere secure, and when I'm finished, I can select Done. Now from here, if you want to revoke a secret key, you just select the trash can icon beside the secret key that you want to remove, select Revoke Key, and the key is revoked and will no longer be usable. Okay, so now over in the left navigation menu, I'll select Usage. And this is the usage page describing my daily usage over the past month. Now if I scroll down, there's a free trial usage section which provides me with a summary of my free trial usage. Now with brand new accounts, you do get some free trial usage. Language models read and write text in chunks called tokens, and the use of the API is based on tokens. You do get some free tokens with a brand new account. Now with my account, my trial period is over. So if I want to use the OpenAI API, I need to set up a paid account by selecting Set up a paid account. Now from here, I select Start Payment Plan. I can specify my payment details, then my usage billing starts. Okay, so essentially in this path, I'm going to be either working with ChatGPT, the web-based application, or I'll be using the OpenAI API to work with the GPT models directly. With that, we've explored some ways that we can work with GPT models. In this demo, we'll perform a simple ethical hacking exercise by leveraging generative AI and the OpenAI API to analyze threat intelligence. All right, I'm on my Windows 11 research machine. Now I've got Visual Studio Code open with a Python script named threat-intelligence-summary open. This code is a Python script that interacts with the OpenAI API to generate text using the GPT 3.5 model. It defines a function called AnalyzeInfo that takes raw data as input and returns a response generated by the GPT 3.5 model. Okay, so let's explore the code. Starting on line 3, I import the OpenAI Python module. Now, as the comment on line 1 states, in order to do this, first you need to install the bindings with pip install OpenAI. So I'll press Control backtick to open a terminal below the code, and down in terminal, I would type pip install OpenAI, and that would install the OpenAI bindings. Now, I'm not going to do that because I've already done that. So let's go on with the code. Okay, so line 6, I specify my API key, and then on line 9, I define a variable named dark web posts, which contains a number of dark web posts that our security team was able to scrape from the dark web. Scrolling down, okay, on line 30, essentially I'm creating the raw data by joining each of those individual entries from the dark web posts. And then, starting on line 33, this is where we're really doing the heavy lifting. So on line 33, the AnalyzeInfo function is being defined. It takes a single parameter, data, which represents the raw data passed to it in the call to the function later in this Python script. Now, lines 34 through 38, we create the engineered prompt. We do this by concatenating several lines of text, including on 38, where the string is formatted to include the data passed in to the AnalyzeInfo function. Okay, now, starting on line 40. Line 40 is where the OpenAI API call is made using the OpenAI.completion.create method. This method creates a completion task which generates text based on the provided parameters. And what are those parameters? Line 41, the engine parameter specifies the engine to use for text generation. In this case, the engine named text-davinci-002 is being used. This engine is a variant of the GPT 3.5 model optimized for generating text. Line 42, the prompt parameter is where we provide the input text or prompt for the text generation. It's set to the value of the engineered prompt string variable. On line 43, the max tokens parameter determines the maximum length of the generated text. In this case, it's set to 250 tokens, which helps to limit the length of the response. On line 44, the end parameter specifies how many different completions to generate. Here it's set to 1, so only one response will be generated. On line 45, the stop parameter can be used to specify a list of tokens that, if generated, will signal the model to stop generating text. If set to none, like it is here, the model will continue generating text until it reaches the max tokens limit. On line 46, the temperature parameter controls the randomness of the generated text. A higher value, for example 0.8, makes the output more random, while a lower value, like 0.2, makes it more deterministic. Here it's set to 0.8, meaning the output will be relatively random. Now, on line 48, after making the API call and receiving a response, this line extracts the generated text from the response object. The response choices list contains the generated completions, and response.choices0.text gets the text of the first and only, in our case, choice. The extracted generated text is stripped of leading and trailing white spaces using the strip method, and then on line 49, it's returned as the output of the AnalyzeInfo function. Okay, and on line 51, this is where we make the call to the AnalyzeInfo function and pass raw data. And then on lines 53 and 54, we simply print the analysis. Okay, so down in terminal, let's run the code. And to do that, I'll type Python and the name threatintelligencesummary.py. And I'll use the tab key to autocomplete and press enter. Okay, so interesting. It returns a summary of posts that we found on the dark web. It tells us that there's a security flaw in Brocadero software, that there's a zero-day exploit, that there's an APT versus critical infrastructure. So I'm going to up arrow to bring the command back And I'm going to run the same command and see if we get something different. Okay, and we get something a little bit different. This time, it actually references a CVE number, which was referenced in the dark web posts. And if we keep up arrowing and run a threat intelligence summary, because we set the temperature to 0.8, we should get something a little bit different even. And we do. This time, it's in the form of a paragraph. With that, we've performed a simple hacking exercise by using generative AI and the OpenAI API to summarize some threat intelligence. In this demo, we'll use generative AI technologies to identify potential attacks. All right, to get started, I'm on my Windows 11 research machine. I've opened my browser and navigated to github.com/frogger, and the O is a 0, /Iatelligence. Iatelligence is a Python script that extracts the import address table from a portable executable and uses OpenAI's GPT-3 model to provide details about each Windows API imported by the file. The script also searches for related MITRE attack techniques and explains how the API could potentially be used by attackers. It also displays the file hashes and provides an estimate of the cost of the GPT-3 requests. The authors note that Iatelligence is their proof of concept for using GPT-3 for malware analysis and for quickly assessing the behavior of a malware based on its import address table. We're going to clone this repo. So I'll select the code dropdown. I'll select the copy icon beside the repo URL. Now down on the taskbar, I'll select the Visual Studio Code icon to bring up Visual Studio Code. Now in Visual Studio Code, I have a text file open, and this text file contains the information that we'll need in order to set up an OpenAI API key environment variable. But first, down in Terminal, let's clone the repo. So I'll type git clone, and I'll paste the GitHub repo URL in and press enter. Okay, so now the repo has been cloned onto my local machine. So over in Visual Studio Code Explorer, I'll expand the new Iatelligence directory that was created when we cloned the repo, and I'll double click to open iatelligence.py script. One of the other things that we'll need to do is install the requirements. And the requirements are listed in the requirements.txt file. So all we'll need to do is go down in Terminal and type pip install -r requirements.txt. Now keep in mind that I'm in the /demo directory, and that requirements file is in a subdirectory Iatelligence. So let's go ahead and do that then. So I'll type pip install -r /Iatelligence /requirements.txt. I'm using tab to autocomplete, and I'll press enter. Now I'll clear the terminal. And now with the IAT script open in Visual Studio Code, you should always keep your environment variables private and never hard code sensitive information directly into your code. So what we'll do is we'll need to alter this script. First, we'll import the OS module. So in the script on line 14, at the end of the line, I'll place my cursor and press enter, and then I'll type import OS. Now we'll need to also modify line 20. I'll highlight the double quotes, and now I'll type os.environ, and in square brackets, and within double quotes, in all caps, OpenAI _API _key. And that should be good. So I'll press Control S to save the file. And so now let's go back over to the text file, OpenAI _API-key.txt. And essentially what we're going to do is we're going to set up an environment variable with my specific OpenAI API key. So I'll highlight line 6, Control C to copy. Down in Terminal, I'll right click to paste the command in and press enter. Now if I want to confirm that the environment variable was actually created, I'll highlight the getChildItem command on line 9, and I'll copy it with Control C. Now down in Terminal, I'll right click to paste the command and press enter. Okay, and the results show that indeed I have set up the environment variable OpenAI _API _key. So we should be good to go. First I'll clear. And now one more quick look at the Python script. Okay, scrolling down to line 74, this is where the script defines the request underscore OpenAI function, and it's expecting the IAT to be passed in. Now, scrolling down on line 97, this is the prompt, and it's a formatted string that includes the DLL name and the import name. Then on line 98, this is the call to the OpenAI API using the OpenAI.completion.create method. Recall that this method creates a completion task which generates text based on the provided parameters. And speaking of the parameters, let's quickly review the parameters. So on line 99, it's using the text-DaVinci-003 engine. If you're wondering what the main difference is between 002 and 003, it's that 003 has been trained on a larger data set, so it should be able to generate more accurate results. 003 can also understand natural language instructions and produce more detailed responses. Okay, now max tokens is set to 2500. On line 101, top P stands for top probability and controls the diversity of the generated text. Frequency penalty on line 102 is used to influence the model's likelihood of generating less common words or phrases. Line 103, presence underscore penalty encourages or discourages the model from including specific tokens provided in the prompt in the generated output. Line 104, of course, is the prompt to send to the language model. And on line 105, we have the temperature. And since this one is set to 0.6, it's going to be relatively diverse and creative. Okay, so now let's run the script and we'll reference a portable executable that I have in my demo directory, which is supposed to be the Visual Studio Code setup binary. So now, down in terminal, I'll type python./iaintelligence/iaintelligence.py. I'm using the tab key to autocomplete, and I need to reference the portable executable .portable_executable.exe, and I'll press enter. Okay, so now the script runs. It gives us the file hashes and provides an estimated cost of the requests. And at this point, it looks like it's going to cost around 29 cents to do this analysis. So just imagine, as ethical hackers, we can go to our organization and demonstrate that, look, we can check this potentially malicious portable executable and determine whether it is actually a malicious file for 30 cents. All right, now this can take upwards of 4 or 5 minutes, and I'll fast forward through this so that we can see how the output appears. The script completes and the report is generated. It provides details about each Windows API imported by the file and explains how the API could potentially be used by attackers. All right then. Well, with that, we've used generative AI technologies to identify potential attacks. In this demo, I used generative AI to summarize information gathered using passive reconnaissance. All right, so imagine that I've done some passive reconnaissance using your typical open source intelligence tools, like just searching the web, using a couple of different search engines, and so on. So we've returned this massive amount of reconnaissance information, and we want to use generative AI to summarize that information for us. Okay, well, I've done exactly that in a script named passive-recon.py. Let's explore passive-recon.py. So on lines 2 and 3, I import the modules that I need, OpenAI and the OS module. Then on line 6, I retrieve my OpenAI API key that I've configured in an environment variable named OpenAI_API_key. Starting on line 9 is the passive_recon_summary function definition. It's in this function where I make the call to the OpenAI.completion.create method. The passive recon summary function takes a single parameter, query, which represents the prompt passed to it in the call to the function later on in the Python script on line 32. We'll get to that in a moment. So on line 10, the OpenAI API call is made using, as mentioned, the OpenAI.completion.create method. This method creates a completion task, which generates text based on the provided parameters. On line 11, the engine parameter specifies the engine for the text generation. In this case, the engine is text-DaVinci-002. This engine is a variant of the GPT 3.5 model, and it's optimized for generating text. On line 12, the prompt parameter is where you provide the input text or prompt for the text generation. It's set to the value of the query string variable. On line 13, the max tokens parameter determines the maximum length of the generated text. In this case, it's set to 100 tokens. The end parameter specifies how many different completions to generate. Here it's set to 1, so only one response will be generated. On line 15, I set the stop parameter to none. And on line 16, the temperature parameter controls the randomness of the generated text. Recall that a higher value, like 0.8 or 0.9 for example, or 1, makes the output more random, while a lower value, for example 0.1, makes it more deterministic. Here it's set to 0.1, meaning the model's output will be more deterministic. And this simply means that it will closely follow what it perceives as the most probable next token based on the input. This often leads to more focused and coherent text, but may sacrifice some creativity in the process. Okay, then on line 18, after making the API call and receiving a response, this line extracts the generated text from the response object. The response.choices list contains the generated completions, and response.choices 0.text gets the text of the first and only, in this case, choice. The extracted generated text is stripped of leading and trailing white space using the strip method. Then on line 19, it's returned as the output of the passive_recon_summary function. Now on line 22, I set up the name of the organization I've gathered the recon information about. Then on line 23, I set up the recon info F string with the information I've gathered using traditional passive recon. Okay, not a huge amount of information, but it's good information nevertheless. Next, on line 31, I create the recon_query F string, which is effectively the prompt used in the call to the GPT model. Then, as mentioned, on line 32, I make the call to the passive_recon_summary function, and the recon_query string is passed in as an argument. Then on line 33, I just print the summary. Okay, so let's run the code. So down in terminal, I'll type Python passive-recon.py, and I'm using tab to autocomplete, and I'll press enter. All right, so that created a summary of the information using the OpenAI API. It tells me all about Unito Games and that it's a Boston-based company, who it was founded by, the number of employees it has, $30 million in revenue in 2023, its top products and services, and so on. Now, if I clear the screen and then up arrow to run the same command again, I should see pretty close to the same output. And it is very close to the same output. And the reason for that, again, is the temperature setting. I have it set to 0.1, so the model's output will be more deterministic. All right, and so with that, we've used generative AI to summarize information gathered using passive reconnaissance. In this demo, we use generative AI to analyze information gathered using active reconnaissance. Okay, to get started in my demo, I've opened my browser and I've navigated to nmap.org/book/man.html. This is the Nmap reference guide. One of the ways that we can start with active reconnaissance is by performing a host discovery using a tool like Nmap, for example. Nmap is a very common tool for just such endeavors. We can use it to quickly find hosts, find any open ports, and then we can focus in on those ports and the services running on those hosts. We can use generative AI to help us analyze all the active reconnaissance information that we've gathered. So let's go down to the taskbar. I'll select the Visual Studio Code icon to bring up Visual Studio Code, where I have a Python script open named active-recon.py. This is a Python script that interacts with the OpenAI API to generate text using a GPT model. Let's examine this code. So lines 2 and 3 is where we import the modules we need. Then on line 6, I retrieve my OpenAI API key that I've configured in an environment variable named OpenAI_API_key. Then on line 9, this is the active recon analysis function definition. Notice that it takes a single parameter, query, which represents the prompt passed to it in the call to the function. And we'll see that later in the Python script on line 37. On line 10, the OpenAI API call is made using the OpenAI.completion.create method, which creates a completion task and generates text based on the provided parameters. And the parameters, they're set from lines 11 down through 16. In a previous demo titled Performing Passive Reconnaissance, I went through each parameter in detail. In this script, though, I want to focus on a couple of parameters. First, note on line 12, I've set the prompt to the query parameter. Then on line 16, I set the temperature parameter to 0.5. Now recall that the temperature parameter controls the randomness of the generated text. A higher value closer to 1 makes the output more random, while a lower value closer to 0 makes it more deterministic. Here, I've set it to 0.5, so it's somewhere in the middle. I want the GPT model to be somewhat focused, but I don't really want it to sacrifice much creativity. Okay, next, lines 18 and 19. This is where I configure my message and return it from the active recon analysis function. On line 22, I define a Python dictionary variable for my gathered intel from active reconnaissance. This kind of dictionary structure is commonly used for organizing various pieces of information, and this includes information about a target during cybersecurity reconnaissance. So I've included the website URL, the web technologies that I've noticed, open ports, and observed pages. On line 33, I engineer the prompt for this exercise, and notice that I specify to the GPT model that I want it to analyze the information and recommend any potential vulnerabilities. The nice thing about this is that if I want to change the prompt, if I want to engineer it differently, I just come here and I change my recon query. Okay, then on line 37, as mentioned, I make the call to the active recon analysis function, passing the recon_query argument. Then on line 38, I print the analysis. Okay, well, let's run this script. So down in terminal, I'll type Python active-recon.py using tab to autocomplete and press enter. And from the analysis, we're informed that the website is using outdated software versions which may contain known vulnerabilities, that the website is not using HTTPS, the website is using a number of open ports which may be exploited, and that it has a number of observed pages which may be targeted by attackers. Now I'll clear and then run the script again, and let's see if we get something a little bit different. And we do. It actually mentions the specific protocols and services that are running and that they may be exploited by an attacker. All right, well, with that, we've used generative AI to analyze information gathered using active reconnaissance. In this demo, we'll perform a scan while leveraging generative AI. Okay, to get started in my demo, I've opened my browser and I've navigated to nmap.org/download.html #Windows. I'm here because we want to install Nmap on Windows. So on this page, locate latest stable release self-installer, select the link, and in the downloads dialog that appears, just select save. And that will save the self-installer to your download directory or whatever your default directory is for your downloads with your browser. Okay, so now that's done. Now on a second tab, I've navigated to pypy.org/project/python-nmap. And we're here because we need to install the Python nmap library, and that'll help us use the nmap port scanner with our Python code. Now we install that with Python pip package manager by typing pip install python-nmap. So we don't need to download anything from this page specifically. Okay, so down on the taskbar, I'll select the Visual Studio Code icon to bring up Visual Studio Code. Okay, so I have a Python script named enhanced-nmap-scanning.py open. We'll look at this code shortly. But down in terminal, first I want to highlight the fact that we need to install python-nmap, and to do that, we can just type pip install python-nmap. Now I've already done this, so when I press enter and it runs, it's going to say that the requirement is already satisfied, and yes, it does. Okay, so Python nmap is definitely installed on this system. Now the self-installer was in the downloads directory, so I'll just go down to the taskbar. I'll select Explorer. I'll go to my downloads directory, and there's the nmap self-installer. Now to install nmap, you simply run the executable. When the user account control dialog appears, select yes, and then just follow all the default settings. Don't change anything, just click next, next, install. And then once it's finished, nmap will be installed. We'll have the nmap Python module installed, and we'll be ready to start working with nmap in our Python code. Okay, so I'll just click next, next, finish, and done. you may need to restart Visual Studio Code if you have Visual Studio Code open. I don't have to because I've already installed both of these. If I type nmap right now, I get a response, and that tells me that nmap is definitely installed. Okay, so now let's look at this code. All right, so lines 2 through 4, I import the Python modules I need. There's a new one now, nmap. Then on line 7, I get the OpenAI API key from my environment variable. Line 10 is the function definition, and the function's name is active_recon_analysis. We've already been through these parameters in previous videos, so I won't go through those again. Okay, next, we initialize a new nmap object. I name it nm, that's on line 23, and I equate that to nmap.portScanner. So that initializes a new nmap object. Next on line 26, I actually perform the scan. I'm performing a scan here for open ports on the 192.168.100.0/24 subnet. And what we do is we pass the name of the hosts that we want to scan, and I'm just, again, specifying the subnet and the arguments, and the only argument I'm specifying here is --open. So that's going to scan for open ports. Next, on line 28, I initialize an empty string for the output. Then, from lines 31 down through 37, I'm essentially iterating through the scan results, and I'm selecting the hosts, the open ports, and their status. Next, on line 40, I specify an F string named recon_query. Now, this is essentially the engineered prompt that's going to be passed to the AI model when I make the call to active_recon_analysis. And speaking of which, on line 45, that's exactly what we're doing. So I equate recon_analysis with the results from the call to active_recon_analysis, and I'm passing in recon_query. And again, that's the engineered prompt that we specified starting on line 40. Next, I generate the outputs for the enhanced scan report. And this report provides an overview of the scan, the query prompt, and the insights obtained from the scan analysis. I'm including the query prompt because I want to see exactly what was submitted to the AI model. And then I simply print out the insights. Okay, so now let's go down into terminal. First, I'll clear the terminal. And now I'll run enhanced-nmap-scanning.py by typing Python enhanced-nmap-scanning.py. And I'll use tab to autocomplete and press enter. This may take you a few seconds. I'm going to fast forward through this though. All right, let's explore this output. So there's the title, Enhanced Scan Report. And then the following is the recon query F string. Okay, so the F string starts with given the following network reconnaissance information, and then it lists all the reconnaissance information that was gathered using the nmap command, right? So that is what's going to be submitted to the AI model, along with the last sentence, please use this information to provide insights for the scan. Below that, I have insights from the enhanced scan, and it tells me that the host at 100.1 has several open ports that may indicate the presence of a web server as well as other services. In actuality, that's my router. The host at 100.129 has several open ports that indicate the presence of a Windows server, including RDP. The host at 100.134 has several open ports that may indicate the presence of a MySQL database server. So it was able to grab that kind of insight simply from the ports that are running on those individual hosts. All right, well, with that, we performed a scan leveraging generative AI. In this demo, we'll leverage generative AI for enumeration. Okay, to get started, I've opened Visual Studio Code, and I have a Python script named enhanced-nmap-enumeration.py open. Previously, I've performed a port scan on a private subnet. The scan showed me that there were several hosts that had open ports. Now, I'm going to go just a little bit deeper by enumerating so I can obtain more information about those hosts. And that's what I'm doing with my enhanced enumeration script. So let's explore the script. From lines 2 through 4, I import the modules that I need for this demo. Note that on line 4, I'm importing nmap. That's the Python-nmap library. And to install that, you just type pip install Python-nmap. Okay, then on line 7, I grab my OpenAI API key from my environment variable that I set up. Line 10 is the function definition for active_recon_analysis. This function is going to use the OpenAI.completion.create method to interact with the GPT model. I'm not going to go through these parameters. I've already done that in previous demos. Okay, now scrolling down on line 23, I initialize a new Nmap object. On line 26, I'm performing an aggressive scan by calling nm.scan. So with the scan method, I pass the hosts, and in this case, it's just my private subnet 192.168.100.0/24 and the arguments -a. -a enables operating system and version detection. So that's what I mean. We want to go a little bit further from our basic port scanning to now where we are enumerating the operating system and version. -a also enables script scanning and traceroute. Okay, so then on line 28, I initialize an empty string to hold the output. Now lines 31 down through 41, I'm iterating through the scan results. I'm going to pull the host, the operating system, its name, how accurate the guess is, the open ports, and their status. That's recon_info. I'm going to pass that as part of my engineered prompt, and that occurs starting on line 44. So recon_query is essentially the engineered prompt. And on line 45 through 48, it says, given the following network reconnaissance information, and it includes all the reconnaissance info that I'm gathering with the Nmap scan, please use this information to provide insights for each host identified in the scan, focusing on any identified operating systems and open ports, especially those running on port 80, 53, or 3306. Then on line 51, I'm equating recon_analysis with the results of the output from the call to the active_recon_analysis function. I'm passing the function, the recon_query, that's again the engineered prompt that I designed starting on line 44. Then starting on line 55 to the end of the file is a report which just provides an overview of the scan. I'm also including the query prompt because I want to see everything that was submitted to the GPT model. I also print the insights obtained from the scan analysis. So down in terminal, I'll type Python and the name enhanced-nmap-enumeration tab to autocomplete and press enter. This can take a couple of minutes because it has to scan through all of the devices on the 192.168.100 subnet. I'm going to fast forward through, but again, just keep in mind that this can take upwards of a couple of minutes. All right, the script has completed and the report has been printed to the terminal. I'm just going to scroll up to the very top of the report. And the reason why I want to include the query string is because I want to see exactly what was submitted, again, to the GPT model. What was submitted, the entire engineered prompt, starts at given the following network reconnaissance information. Then it includes recon info, which is all the information gathered by the reconnaissance performed using the nmap command. Then to complete the prompt, please use this information to provide insights for each host identified in the scan, specifically focusing on any identified operating systems and open ports, especially those running on port 80, 53, or 3306. Then the end of the query string notification. Okay, and then below we have some insights. It tells us that 192.168.100.1 is most likely running Microsoft Windows 11 21H2, FreeBSD, or some other operating system, and it has 4 open ports. Interestingly, that is my router, so it's dead wrong here. 100.128 does not have any identified operating system or open ports. It's well protected. Host 129 is most likely running Microsoft Windows 7, Windows Server 2008, or 2008 R2, Windows 8, or Windows 8.1 Update 1. It also has a number of open ports. The fact that it's running such an old Windows operating system, the version information tells us that there may be some significant vulnerabilities there. Okay, so continuing on, and it tells us that 100.134 is most likely running Microsoft Windows 10 1607, And 100.2 is most likely running VMware Player, virtual NAT device, and so on. We were able to take the reconnaissance information that we had based on the Nmap scan, and we were able to analyze that using generative AI. In this demo, we'll leverage ChatGPT to help our ethical hacking efforts by helping us calculate the CVSS score for a discovered system vulnerability. Okay, to get started, I've opened ChatGPT and signed in with my account. For this demo, I use GPT 3.5. To get started, let's just review the Common Vulnerability Scoring System, or CVSS. So the CVSS rates the severity of security vulnerabilities using a numerical score. It considers factors like how an attacker can access the system, the difficulty of exploitation, and the impact of a successful exploit. The resulting score helps prioritize and manage vulnerabilities, with higher scores indicating more severe issues. Okay, so let's use ChatGPT to calculate the CVSS score and associated vectorial string for a discovered reflected cross-site scripting vulnerability. Okay, to start out my prompt, I'll give it some context. I'll tell ChatGPT, I've discovered a reflected XSS vulnerability on my web page at : I'll press Shift-Enter. I like to separate any contextual information from the information that I want it to analyze. Okay, so now I'll specify the URL. I'll press Shift-Enter a couple more times to create some separation. And now my prompt will ask the question. Could you please calculate the CVSS score for this vulnerability so I can include that in my report? And I'll ask it to please share both the score and the CVSS vectorial string. So now let's submit this to ChatGPT and let's see what it comes back with. Okay, and returns with a fairly comprehensive breakdown. First, it tells me a little bit about the CVSS score and how it's a standardized method for assessing the severity of security vulnerabilities. And to calculate the score, that we'll need to evaluate several factors, and it breaks these factors down. So it breaks down the attack vector, the attack complexity, privileges required, user interaction, scope, confidentiality impact, integrity impact, and availability impact. Based on that, it tells us how to calculate the CVSS base score, and it gives us the numbers. So we've got the impact, we've got the exploitability, and now we plug these values into the CVSS base score formula, and the CVSS score for the reflected cross-site scripting vulnerability is 0.938. Then it gives us the vectorial string for the vulnerability. I'll ask it to provide me with a qualitative assessment of this vulnerability based on the CVSS score. Okay, now I'll submit the prompt. All right, in the output, it comes back and ChatGPT tells us that this is a low severity vulnerability. It tells us the likelihood of exploitation, the impact, the scope, and the overall assessment. Now, the more information that we can provide to ChatGPT, the more information that the generative AI model can create for us, and the more accurate that information will be. So just keep that in mind as you're using prompt engineering with AI models like ChatGPT. In this demo, we'll test the security of a system utilizing generative AI to drive the process. First, a little bit of background information. We're going to be running an Apache Struts application. Now, Apache Struts is an open source MVC framework used for creating Java web applications. It integrates the log4j library, and depending on the version of log4j, it may be vulnerable to a log4shell remote code execution attack. Affected versions are included in some Apache projects like Struts, Apache Solr, and others. According to the docs that we've been provided with by the client, it appears that they're using Struts 2.5.28, which integrates log4j 2.12, which is potentially one of the vulnerable versions of the logging library. Let's get ChatGPT to help guide our process to test this system. We want to confirm the versions of log4j 2 that have vulnerabilities, what their respective CVE numbers and severities are, and how we can test for them. Okay, to get started, I've signed into ChatGPT in my browser. And first, I'll ask, please list any vulnerabilities for log4j 2 logging library, including CVE numbers and associated severities. All right, and it comes back with a few vulnerabilities, all the way from low to critical in severity. Okay, so now let's follow this up. So I'll type, I know our version of Apache Struts integrates log4j 2. Could you tell me how I can test to see whether our servers are vulnerable? All right, ChatGPT comes back with a number of recommendations on how to test. Let's make this easy on ourselves. We'll start with number 1, checking the log4j version. Okay, and I can use a find command for that on the file system. So I'll follow up with another prompt. Could I use a find command on my Linux system to search the entire file system for any files or directories that start with log4j and then pipe that into grep 2.12 to filter the results for the existence of files or directories that start with log4j but also have 2.12 in them? Okay, and ChatGPT comes back with a fairly complicated find command. It's not exactly what I was looking for. I noticed that in the recommended command, it's specifying the type. I don't care about the type. I want files and directories. And I know that if I don't specify either in the find command, by default, it will include both. So let's get ChatGPT to refine the command. So I'll prompt it with, why do I need to specify the type? Wouldn't this command do? And I'll type find /-name log4j asterisk and pipe that into grep 2.12. And ChatGPT comes back and indeed agrees that we could use the find command without the type option. So a much simpler command. And this will find any existence of a file or directory that starts with log4j and has 2.12 anywhere in the name. Okay, so with that, let's go over to my Kali Linux machine. Okay, so here I am on my Kali 2023.3 penetration testing machine. Now I happen to have a Docker file that I can use to run the application. Okay, so to get started, up in Panel, I'll select the terminal icon to open a new terminal. And the first thing I'll do is update the apt package list, and I'll install Docker so that I can build an image of our struts Java web application. I'll then run that image, effectively creating a container, and that container will listen on port 8080. This is all contained in the Docker file, and I'll include that file in the assets for this demo. Okay, so to install Docker, I'll type sudo apt update && sudo apt install -y docker.io. Pressing enter. Okay, and done. Now, if you see an outdated processor microcode message, you can just ignore it. So I'll press enter to select OK. And now back in terminal, I'll type ls. And I've created a folder named struts-docker. If I cat out the Docker file in struts-docker, that shows the contents of the Docker file. So we're going to build a struts2 2.5.28 image and then run the image to create a container with the affected software. Potentially affected software, that is. Okay, so let's build the image. To do that, I'll type sudo docker build /struts-docker -t struts2 2.5.28 and press enter. Okay, and now the image has been built. Now we can run the image. To do that, I'll type sudo docker run --name and we'll name the container struts2. I'll type --rm and that removes the container when we're done. -p, and that's the port we want the application to listen on. That's port 8080. So I'll type 8080:8080 and the name of the image that we're going to run, struts2 2.5.28. Okay, I'll press enter. All right, and now the struts application is running. Now if I go up to Panel and open my browser, so I'll select the Firefox icon in Panel, and in the address bar I'll type http://192.168.100.129, that's the IP address of this Kali Linux machine, :8080, that's the port it's listening on, /struts2-showcase. Okay, and that brings up the struts2 application. I'll go back up to Panel, and I'll start another terminal. Okay, now this time, let's use the find command. So I'll type sudo find / because I'm going to go from the root directory -name, and we're looking for a file with the name starting with log4j. So I'll use an asterisk wildcard at the end of log4j, and that's all delimited in single quotes. And I'll simply pipe that all into grep 2.12. Now remember, I'm specifying grep 2.12 because I know from the client that their version of struts2 integrates log4j2 2.12. So now pressing enter, and in the output, I notice several jar files using log4j2 2.12. So this application is definitely vulnerable. Okay, so now at this point, I've determined that they are affected, they have vulnerable servers running, and they need to address the vulnerabilities ASAP because recall, some of the vulnerabilities were severe. Okay then, with that, we've tested the security of a system utilizing generative AI to drive the process. In this demo, we'll leverage generative AI to report system vulnerabilities and recommend steps for mitigation. Okay, to get started in my demo, I've opened Visual Studio Code and I have a file named engineered-prompt.txt open. In this file, I have two parts that we're going to use with ChatGPT. One of the things about generative AI that we can use it for and create great efficiency from is in creating reports. So in part one, what we're going to do is we're going to ask ChatGPT to assume the role of a cybersecurity expert, that it's well known for its cybersecurity acumen and its clear and concise writing skills. Then in part two, we'll indicate that we've discovered some vulnerabilities. We'll give the CVE numbers, the operating system, and we're going to supply it with a template report. And we're going to have it create a professional vulnerability report for us. Okay, so let's go to line 2. I'll highlight line 2, Control-C to copy. Now down on the taskbar, I'll select the browser icon to bring up my browser where I've signed into ChatGPT. In the send a message field, I'll press Control-V. And again, I'm telling ChatGPT to assume the role of cybersecurity expert and that it's well known for its cybersecurity acumen and clear and concise writing skills. So let's go ahead and submit this prompt. Okay, and ChatGPT comes back and indicates that absolutely it does understand that it's going to assist us with cybersecurity related questions and provide information in a clear and concise manner. Okay, so now let's go back down to the taskbar. I'll bring Visual Studio Code back again. Let's just explore part 2 a little bit further. So on line 5, essentially, I'm indicating that I've discovered some vulnerabilities on a Windows 11 operating system. I reference the CVE numbers. Then below, starting on line 7, I indicate to ChatGPT that I have the outline of a vulnerability report. But here's the thing. This one was templated for one vulnerability only. And we're asking it to follow the format, but expand it to include a second vulnerability. Then below that, starting on line 9, in double quotes, is the template. So I have a title, and anywhere in square brackets, it's going to provide the information based on what I've asked it to do. Then I have an executive summary, the vulnerability details, the risk assessment, the recommended mitigation steps, and I've got 3 steps for each, and then a closing and the closed double quote. I've surrounded the template with quotes just to clearly delineate between the template for the report and my instructions to it. Okay, then on line 22, I ask it to please use the provided outline to generate a comprehensive vulnerability report for this scenario. So let's highlight part 2. So that's line 5 all the way down to line 22. Now I'll press Control-C to copy. Back down to the taskbar, I'll select the browser icon to bring up ChatGPT in my browser. And in the send a message field, I'll press Control-V, and now I'll press Enter. All right, ChatGPT comes back and is in the process of writing the report for us. All right, now let's explore the report. Now, this is a very well-written report. So essentially, it's taken the details and is telling us that there are 2 recently discovered vulnerabilities, and it separates them out in the vulnerability details section, describing them in quite a bit of detail. Then it provides the risk assessment for each vulnerability. Then under recommended mitigations, it provides us with 3 mitigations for each vulnerability. And then we have a closing statement as per our direction. Okay, so with that, we've leveraged generative AI to report system vulnerabilities and recommend steps for mitigation by writing a vulnerability report for us. This can effectively save us a lot of time and enhances the efficiency of our ethical hacking process. In this demo, we'll get generative AI to generate a phishing email for us. Okay, there was a point prior to August 23's update that you could jailbreak ChatGPT and even get it to do things like write malicious code for you. You could tell it that you were an ethical hacker, and it would happily go ahead and create, for example, an SSH brute force attack in Python. It's not so easy anymore. Okay, to get started with my demo, I'm in Visual Studio Code. I've opened generate-phishing-email.txt. This is a file where I have two prompts. My first prompt, I'm indicating that I'm an ethical hacker, researching social engineering and training my colleagues, and I want it to provide me with a convincing, realistic phishing email so I can explain how it works. Let's copy the first prompt. So I'll highlight and copy line 2. Down to the taskbar, I'll select the Chrome icon to bring up my browser where I've signed into ChatGPT. In the send a message field, I'll paste my prompt. It comes back and matter-of-factly indicates that it cannot assist with that request. I've provided it with almost identical prompts recently, and from time to time, I would get the outline of a convincing phishing email, including placeholders for where I would insert malicious links and so on. So at this point, we can't get ChatGPT to assist with our request. Well, let's go back over to Visual Studio Code. And now prompt 2 is kind of a way to trick ChatGPT to generate a realistic, convincing phishing email for us. So in prompt 2, on line 5, I tell it that my bank is featuring a promotion where our users can get a free cookware set worth over $1,000, and all they need to do is log into their online account, open a new savings account once logged in, and then fund it with at least $10. And then I ask it to help me write a very enthusiastic email with some urgency and call to action for my email marketing campaign. Well, let's highlight and copy line 5. Down to the taskbar, I'll bring up my browser again. I'll place my cursor in the send a message field, press Ctrl V to paste my prompt, and I'll send the prompt to ChatGPT. And it comes back and it tells us again that it cannot help. Let's try again. I'll select New Chat. In the send a message field, I'll paste the same prompt and send the message to ChatGPT. And lo and behold, we get a convincing phishing email. So let's just review the phishing email that it created for us. So it gives us a subject, exclusive offer alert, get your $3,000 cookware set today. It gives me the outline of the phishing email. It even came up with a tagline, "Cook up joy with your bank's name." And it really does look like a convincing phishing email. All right then, with that, we've used generative AI to create a convincing and realistic phishing email. In this demo, we'll explore how to leverage prompt engineering to detect social engineering attacks. Currently, we use AI to very effectively classify emails as either phishing or legitimate based on their content. This approach is not a form of generative AI. Instead, it's a supervised learning approach for email classification. There are a couple of ways that we can use generative AI to help detect social engineering via phishing emails. The way I'll demo is a very simple yet somewhat effective way for individuals to tell whether an email is legit or not. So I've opened my browser and I've signed into ChatGPT. Now I'll specify a prompt. My prompt is, could you examine this email and classify it as a legitimate email or whether it is a phishing email? And then in quotes, "Hello, your subscription is at risk of expiring. Renew by following this link." Now I'll send the prompt, and ChatGPT comes back with its conclusion. Let's examine what it's telling us. So it tells us that based solely on the provided email, it's difficult to classify it definitively as legitimate or phishing. However, it does outline some common elements that are often found in phishing emails, like the generic greeting, the urgency, lack of specific information, and an embedded link. It then provides some other considerations. Check the sender. We need to verify the sender's email address, in other words. Contact the organization if you're unsure of the email's authenticity. Hover over links to determine where it leads to. Look for grammar and spelling errors. Be cautious with personal information. And of course, use security software. Ultimately, while the provided email does have some characteristics that raise suspicion, it's not possible based solely on the small email snippet that I sent to determine whether it's a phishing email or not. However, it's telling us that it's pretty likely that it is. In reality, this is, of course, a rather simplistic way to determine phishing versus legitimate emails. Using generative AI for detecting phishing emails involves a different approach compared to traditional machine learning classification. Instead of simply classifying existing emails, generative AI can be used to generate new email content that mimics phishing attempts, allowing organizations to test the effectiveness of email security measures or train a classifier on generated data. It's a fairly involved process that's beyond the scope of this course. It involves things like data collection and pre-processing to gather data sets of legitimate and phishing emails. Then we train a generative model. Then we generate emails using the generative model. Then we evaluate and test. Then we train a machine learning classifier and perform regular testing and updating. Nevertheless, as demonstrated here, even performing a simple analysis like this using ChatGPT does give us some notion that the email content I submitted is a phishing email. All right, well, in this demo, we leveraged prompt engineering to help detect social engineering attacks. In this demo, we'll perform a simulated social engineering attack and demonstrate how to counter it. For this demo, I'm going to be using a utility called play.ht that allows me to clone my own voice. Now, on the left side, I have play.ht open and I've signed in. On the right side, I've got Microsoft Edge opened up and I've navigated to play.ht. I haven't signed in. I wanted to demonstrate how to sign up for a free account. So navigate to play.ht, then select the nav menu icon, and now from the menu, select Try for Free. That brings you to a sign up page where you can either sign up with a Google account or you can use your own email. Okay, so let's go over to Chrome browser and I'll maximize Chrome browser. All right, so this is the interface in play.ht and I'm in the studio part. Okay, what I'm going to do first is I'm going to select voice cloning in the left-hand menu. On the voice cloning page, it shows that I've cloned one voice. That's my own. To clone a voice, just select Create a New Clone, then select Instant. I'm on the free plan, so even though there are some limitations, I can clone one instant voice. Okay, so that's what I've done. Now, how do we use the cloned voice? Well, I'm going to go to Files. Now it shows that I have no audio files here. So I'll select Create New File, and we'll use Generative Beta. So this provides me with several voices that I can choose from, including my cloned voice. So I'll select Generative Beta. And right now it's showing the default voice. I'll select the default voice, and that brings up the choices that I have. I'll choose my own voice, which is clearly shown as being cloned. Scroll down and select Confirm. Okay, so now what I need to do is type or paste in some text, and play.ht will use my cloned voice with that text. So I'll press Ctrl-V, and as the text shows, it says, "Hello dear, could you tell me the password for our Amazon account? I can't remember it, and I need to get in to cancel a very expensive order." So to generate the audio for this text, I'll select the start icon. "Hello dear, could you tell me the password to our Amazon account? I can't remember it, and I need to get in to cancel a very expensive order." Okay, so that sounded amazingly like my own voice. And all I submitted was a 1-minute WAV file to play.ht. And it was able to clone my voice based on that short 1-minute WAV file. Okay, so in performing a social engineering attack, I would use this audio and potentially call my partner and get her to tell me the password for our Amazon account. These types of social engineering attacks are very dangerous because, like the executive that had 220,000 euro transferred to a hacker's account, these types of attacks can be very fruitful for bad actors. So how do we protect against it? One countermeasure is employee education. It's necessary because users need to understand common social engineering tactics. Regular training sessions and simulated attacks can reinforce knowledge and readiness. It's important to understand the potential threats posed by generative AI, like deepfakes or AI-generated phishing emails, and education is one key method that can help. Users can also benefit from shared real-life examples and case studies of social engineering attacks to illustrate the potential impact and consequences. Providing stories about successful attacks and how they were carried out can help users really understand and retain the knowledge. It can also help users realize the importance of the training that they're participating in. In addition, a security-conscious culture is becoming increasingly important for organizations. There are so many threats and burgeoning advanced threats posed by technologies like AI, for example. So organizations can't afford to be complacent. And naturally, education and training is a key component of a security-conscious culture. There should also be strong security policies in place. This involves the creation of comprehensive policies addressing password management, dissemination of sensitive data, transferring funds, and so on. Security policies must be updated to include AI-generated threats across all potential attack vectors. Regular audits and checks help ensure adherence to policies. One other countermeasure is AI-based detection tools. AI-based tools can be used to detect anomalies and patterns that might indicate an AI-generated attack. In this demo, we use generative AI for sophisticated network vulnerability discovery. All right, to get started in my demo, I have a couple of files open in Visual Studio Code. I have WD, which stands for wired, _vulnerability_with_follow-up. So that's wired vulnerability with follow-up. And I also have GPT-3 Nmap scanning. Now this script uses a GPT-3 model, and we're going to be using GPT-4 with the newer vulnerability scan. I've also included OpenAI API key.txt just to remind that we set an OpenAI _API _key environment variable, and we'll be using that when we interact with the OpenAI API. Okay, so back to wired vulnerability with follow-up. Let's examine this code. On lines 4 through 6, we're importing the libraries and classes that we need. And this is one difference that we have versus the GPT-3 model. In line 4, we're importing the OpenAI class from the OpenAI module. In the GPT-3 script, we simply imported the OpenAI module. Okay, now further on line 5, we'll be using Nmap to perform our vulnerability scan. And then we import sys. We'll be using that in a loop that we're using later on. Okay, so another difference is that we're going to instantiate a client object like we're doing on line 11, and that will interact with the OpenAI API. That is why we imported the OpenAI class on line 4. Note also that if no API key argument is explicitly specified, then the OpenAI class will attempt to retrieve the API key from an environment variable named OpenAI _API _key, exactly as we specified earlier. So we don't have to specify anything here. And in fact, on line 11, we haven't specified any API key. It's going to extract it from the environment variable. Otherwise, we could specify the API key and pass it as a parameter when we instantiated the client object. Okay, so scrolling down, and notice I've got a fair amount of comments here, and that's because there are quite a few changes between GPT-3 and the GPT-4 models when interacting with the OpenAI API. So it's as simple as this. The GPT-3 model that we used earlier uses the completions API, whereas GPT-4 only supports the chat API. And there are some major differences going on here. Let's go over to the GPT-3 script one more time. Notice that when we define the function that calls the OpenAI API, we pass a query, okay, and then we make a call to create. And this no longer works with GPT-4. We specify as a parameter the engine, that's a GPT-3 variant, and with the previous model, when we wanted to query the GPT model, we specified that in a prompt parameter, as shown on line 13. Okay, back to the wired vulnerability with follow-up script. Okay, so in our function definition on line 20, we specify two parameters, previous messages and new user message, and new user message has a default of none. Then on line 21, I'm checking to see if there is a new user message. And if there is, then I'm appending it to previous messages. And that way we'll keep track of the messages that we're sending to the GPT-4 model. Okay, now newer versions of the OpenAI Python API library don't support the chat completion attribute anymore. They did at one point. But the newer API client has a chat attribute and a method completions.create. And this is what's used to interact with OpenAI's chat-based models like GPT-4. And note on line 24, when I make the call to completions.create, I specify a model, not an engine, GPT-4 on line 25. Then instead of prompt, we specify messages, a list of messages that makes up the conversation with the GPT model, and it supports multi-turn queries. What this does is it allows us to maintain context and continuity throughout an interactive session with the GPT model. Now, one other parameter that I want you to be aware of, on line 27, we set the temperature at 1, so that's about halfway. And then on line 28, max tokens, this defaults to infinity. So it's a good idea to set it at a reasonable value, so I set it at 500. So again, this is quite a bit different than GPT-3 that we've used earlier. Okay, on line 30, we return the response, and we also return previous messages, because again, we want to keep track of the messages and be able to accumulate them so that we maintain context and continuity throughout our interactive session. Okay, lines 32 down through 47, we're essentially doing the scan, the vulnerability scan using Nmap port scanner, and then we're formatting the scan results. Then on line 49, I define another function, print analysis, and I pass it response, and it's essentially just going to extract and print the analysis message from the chat response. Now, on line 56, I specify a variable, previous messages. So this is my list of messages. So you essentially specify a role, and on line 57, the role is system. So this is for the GPT model. Then for content, I specify you are a master cybersecurity analyst and researcher. On line 58, the role is user, so that's me. And I'm specifying the content to send to the GPT model. Analyze these results from an Nmap scan and give me some recommended exploits, including CVE numbers for reference. Then on line 59, I specify another message. The role is user again, and the content is the recon info that we got from the Nmap vulnerability scan. Okay, line 63, this is where I make the call to start chat session. I have two values that are going to be returned, recon_analysis and previous messages, and I pass previous messages as well. On line 66, I make a call to the print analysis function, and I pass recon analysis. And on line 69, I set up to allow for follow-up questions. So essentially, if I have a follow-up question, I can type it. Otherwise, I type exit, and that will end the session. Now, line 71, that's the start of the loop. While true, on line 72, follow-up equals, and I'm using input to get a follow-up question from the user. On line 74, if follow-up is exit, then I'll exit the session with an exit code of 0. On line 79, I have two values that are going to be returned, recon analysis. This is the new recon analysis based on the follow-up question, and previous messages. And then I pass in previous messages and follow-up. So follow-up, if we go back up to our function definition, follow-up is being passed in, and it will end up being the new user message. Okay, finally, on line 82, I print the analysis. Okay, so the first thing that you might want to do is just check the version of the OpenAI module that you have installed, or just directly upgrade it. So I'll type pip install --upgrade OpenAI, and I right arrowed to autocomplete. Now, if I type pip show OpenAI, it shows that I have version 1.1.1 installed. Okay, so now let's make the terminal quite a bit bigger, and let's run the script. So I'll type Python wd vulnerability with followup.py. I'll autocomplete with the right arrow key and press enter. Now this is doing a scan on the entire 192.168.100.0/24 subnet. So it may take up to a minute or maybe a little bit longer. Depends on how many devices you have on your network and their complexity and so on. Okay, and there is our analysis. We have 3 hosts in total that it was able to identify. 192.168.100.1. This is basically associated with my VMware server. I use VMware for my virtual machines. We have a second host, 192.168.100.128. This has a couple of ports open, but the one that I find interesting is 100.140. So this has an RDP port open, and it also has port 5900 open. Notice that it references the CVEs describing the vulnerabilities associated with these open ports and their services. Okay, and notice at the bottom of the screen, if you have a follow-up question, type it now. Otherwise, type exit to end the session. So I'm going to specify a follow-up question. I'm going to ask about port 5900. I know that's a VNC port. So I'm going to ask it, if I know the credentials of 100.140, then I can just connect using a VNC client, right? So to maintain the continuity and the context, it's actually going through the previous messages and it's adding this message. It specifies, yes, if you have valid credentials, you're able to connect directly using a VNC client due to the fact that port 5900 is open. And it mentions, as I'm aware, that port 5900 is the default port for VNC services. And it also reminds me that I need to follow ethical guidelines when performing penetration testing. Now I'll just type exit to exit out of the program. Okay, so with GPT-4 then, we can take advantage of the way that the API is designed to easily allow follow-up messages and multi-turn conversations with the messages parameter. All right then, with that, we've used generative AI to perform a sophisticated network vulnerability scan. In this demo, we'll use generative AI to help monitor and analyze wireless network activity. Okay, to get started in my demo, I have a couple of files open in Visual Studio Code. I have WL, which stands for wireless, _packet _analysis.py open. I've also got synth _WL _packets _mixed.py open. The latter is going to be used to synthesize some packets that we can analyze with GPT-4. So I'll select the second tab. Now this script imports Scapy, and that's the key ingredient in this script. Scapy is a powerful interactive packet manipulation program and library for Python. We're going to import some functions from the Scapy library and use them to synthesize wireless network packets. I'm not going to spend too much time going over the code. It's fairly simple. We import the libraries that we need. We create a list of authorized MAC addresses as well as an unauthorized MAC address. We generate the SSIDs of the network. We create an empty list to hold packets, and then we create the packets in a for loop. We're going to create 10 packets, and one of them, only one of the 10, is going to include an unauthorized MAC address. The work in creating the packets is done on line 28. This is where we use the modules from the Scapy library to create the network packet. Then on line 29, we append each packet to a packets list. At the bottom of the script on line 32, we use WR pcap to write the list of packets to a pcap file or a packet capture file. And we will analyze the network activity from that packet capture file. So let's go to the wireless packet analysis script. Okay, on line 1, I import PyShark. PyShark is a Python wrapper for T-Shark, a network protocol analyzer that's part of the Wireshark project. It allows Python scripts to access and interact with packet data captured by T-Shark. PyShark provides a Pythonic interface to T-Shark's functionality, making it easier to automate analysis, extract fields, and interact with packet captures within Python applications. For this demo, we also need Wireshark installed on the system. When you install Wireshark, T-Shark is also installed as part of the package. PyShark calls T-Shark processes and parses their output. So without T-Shark available on the system, PyShark will not function. Okay, so now for the rest of the code. On line 5, we initialize the OpenAI client, and recall that it's going to grab the OpenAI API key from the environment variable that I've created earlier. On line 7, we define the analyze capture function. We pass in the packet capture file path. Then we load it on line 9 using PyShark file capture. And then starting on line 12, we iterate over each packet and create a summary packet by packet. On line 19, we create a packet summary of an individual packet by using the extracted information from the PCAP file. Then we send that data to GPT-4. On line 22, we use the completions.create method, and we specify the GPT-4 model, and our message is include for the system. On line 25, you are an AI that analyzes network traffic, and for the role user, the content, authorized MACs only include, and I include the authorized MAC addresses. And then on line 27, user role again, I'm passing the GPT-4 model the packet summary for this individual packet. Down on line 34, we process the response from GPT-4, and then we print it out on line 35. And of course, line 37 is where we call analyze capture and pass it the PCAP file path. Okay, so let's get started. So first, I'll make terminal just a little bit bigger. Now, one thing I would like to bring up is this readme.txt file that I've also included. It contains all the information regarding PyShark, Scapy, and Wireshark, and the OpenAI API key.txt file, just as a reminder that we have this OpenAI API key already configured. Okay, so now down in terminal, I'll type winget search Wireshark, and that shows one software version, and the ID is Wireshark Foundation.Wireshark. So now I'll type winget install Wireshark Foundation.Wireshark, press enter. It notifies us that it found an existing package installed, and I already installed it, of course. So now if I type winget list, that lists all the packages that are installed on this system. The column on the far right is source, and many of these are sourced by winget. So that means that I installed these packages using winget. And if I scroll back down, I'll find Wireshark. And of course, it has been installed using winget. So the next thing is to install the modules that we need for our scripts. And for that, I'll type pip install Scapy space PyShark. And that's both of the modules that we need for this demo. And when I press enter, it's going to tell me that the requirement's already satisfied, of course, because I did install these already. Okay, so now let's run the scripts. First, we'll synthesize some packet capture data. So I'll type Python, start typing synth, and then autocomplete. Okay, so now with the program having run, the packet capture file is created in the current directory. So if I do an ls, notice the mixed_attempts.pcap. That's the file that we just created. Okay, so now let's analyze the network activity in that file. So I'll type Python wl_packet_analysis.py and press enter. And I'll make the terminal a little bit bigger. Okay, and the analysis for packet 1 comes up. And it tells us that this packet is authorized, tells us the source MAC, and that it's a broadcast packet. Packet 2 is similar, it's also authorized. And packet 3, there's the unauthorized packet. Okay, now it continues on till it gets to the end of the packets list, which is packet 10. All right, so using generative AI, we're able to analyze our wireless network activity that we synthesized. To put this into real perspective, imagine if we had a packet capture file that had millions of lines of activity, so millions of packets. We could analyze those packets using generative AI and determine whether there's threats, some vulnerabilities, whether there is an attack going on, the footprint of the attack, and so on. All right, well, with that, we've used generative AI to help monitor and analyze wireless network activity. In this demo, we conduct a simulated generative AI-driven attack on a wired network. Okay, to get started in my demo, I'm on a Kali Linux machine. I've opened my browser and I've navigated to github.com/pvanfas/socialfish, and that's PHISH, social fish. Social Fish is a very complete phishing tool. It has 32 templates plus one customizable template. We'll use it to generate a fake Instagram login form from which we can harvest the credentials from our target. All right, on the page, I'll expand code. I'll select the copy icon to select the GitHub URL for this repo. Now I have a terminal open. So up on the panel, I'll select my terminal icon to bring up my terminal. And now in terminal, I'll type git clone, I'll right click, and I'll select paste clipboard. And now press enter. Okay, so now that repo has been cloned locally. If I do an ls, notice that I now have a social fish directory. I'll cd into the social fish directory, and I'll run the social fish shell script by typing socialfish.sh. I'll tab to autocomplete and press enter. So as mentioned, there are 32 templates and one custom template. I'll specify 01 for Instagram. For a port forwarding option, I'll specify 01 for Servio.net. I'll just leave the default port by pressing enter. And now behind the scenes, it's starting the PHP server. All right, now we're ready to go. So beside send a direct link to target, I'll right click the link and I'll select copy link address. Okay, so now what I've done, I went to ChatGPT, signed in, and I asked it if it could write me an email to inform our users that there's been suspicious activity on their account and that they should log in to confirm that their accounts are okay. And what I got back was beautiful in terms of very convincing, that is. Okay, so far we've generated a form and I've got ChatGPT to write me a very convincing phishing email, although I didn't tell it it was a phishing email. So how do we prevent these types of phishing attacks? Well, one of the best ways is through education. Users should be aware of the tactics and techniques commonly employed in phishing attacks. The more aware they are of these tactics and techniques, the more likely it is that they'll be able to spot phishing attacks or phishing emails like the one that we're about to create here. Okay, so what I did was I took the response that I got, and I'll go to my third tab where I have Gmail open, and I created a template with the content that was generated by ChatGPT. So if I select Compose, first I'll expand my email canvas. Now at the bottom of the canvas, I'll select the More Options icon, and I've enabled templates for this Gmail account. So if I point to templates, under Insert Template, I have one template, Phishing, Urgent, Suspicious. I'll select that one, and that populates the email with the content that I copied from ChatGPT. Let's just clean this up a little bit. So at the very top, I'll remove the forwarding information. Okay, looks good. Now I'm going to scroll down and I'll place my cursor in the hyperlink and I'll select Change. And I'll replace the web address with the social fish link and I'll select OK. Now I'll specify a recipient. My target email is rccsdevops@gmail.com. I'll select send. Okay, so now my target should get that email. Now I'm going to go over to a second machine where I have my Gmail open. And this is an Ubuntu Linux machine. And the email hasn't quite come in yet, so I'll press refresh. Still nothing. Okay, and there it is. So I'll select the phishing email. So again, if I was a user, educated and aware, I would realize that this is a phishing attack. Okay, so now if I scroll down, I'll select click this link. That opens a new tab in my browser with what appears to be a legitimate Instagram login form. Now I'll specify my login information, select login, and of course that doesn't really log me in, it just brings up the real Instagram login form. Now let's go back to my Kali Linux machine. Select the terminal, and lo and behold, I have just harvested the credentials for my target. Okay, so something that we've learned throughout this course and throughout this path is that reusing passwords is really not a great policy. And this is the reason why. So I've just harvested these credentials. Now I've performed a vulnerability scan prior, and I found out that this user's machine has a VNC port open. So now I'm going to try these credentials with a VNC viewer, which comes pre-installed on this version of Kali Linux. Now, if you're not familiar with VNC, It's remote connectivity software that allows you to take over a machine. The machine on the other side, the remote machine, must be running VNC server. VNC servers have port 5900 open. That's the default port for VNC. So I have a VNC viewer on this Kali Linux machine, and I'm going to use it to connect to the remote machine. So I'll type VNC viewer, press enter. Now in the dialog that appears, I'll type 192.168.100.140, and now the password form appears. I'll enter the password that I just harvested from my social phishing attack, press enter, and lo and behold, I now have a VNC connection on my target's machine, which means I have full control over their machine. Okay, so this is where a lot of network and perimeter hacking attacks originate. It's common for attackers to harvest users' credentials and then use their victims' credentials to gain access to the network. Then once inside, they can take their time, stay stealthy, and find the valuable targets that they're looking for. In fact, that's what happened with a famous ransomware attack, the Colonial Pipeline attack in 2021, that shut down an entire pipeline, causing a real disruption to fuel supplies across the eastern United States. All right, and with that, we've conducted a simulated generative AI-driven attack on a wired network. In this demo, we perform an AI-assisted SQL injection attack. To get started, I've opened Visual Studio Code with the files I'm going to use for the demo. First is vulnerable web app.py. Now this is a Python script that's going to run a vulnerable web application. Let's look at the code. Starting from line 1, these are the imports from the Flask framework. The Flask framework is the base class for our application. Request is used to access incoming request data, and render template string is for rendering templates from a string directly. Then import SQLite 3 on line 2. This imports the SQLite 3 database module, which is a lightweight disk-based database that doesn't require a separate server process, and it comes with Python. Line 4 is a fundamental part of setting up a Flask application in Python. Just understand that it initializes a new Flask web application, and it's the starting point for building a web app using the Flask framework. Okay, now I'll expand line 7. This is the database initialization function. This function sets up the SQLite database. The database named example.db will be created in the same directory as the script if it doesn't already exist there. So it creates and connects to example.db, drops the users table if it does exist, and then recreates it, and then inserts a default admin user. This setup is done each time the application starts, so that ensures that we have a clean slate for testing. On line 28, we call the initdb function that we just went over, and then, expanding line 31, we have the querydb function. So this function is used to execute SQL queries on the database. So it takes a SQL query string and optional arguments for the query and a flag to return only one result. We're establishing a connection to the SQLite 3 database named example.db. We're creating a cursor object, C, which will be used to execute the SQL query. Then we execute the query on line 34. We fetch the results into a return variable named RV. Then we close the database connection and return the values. Then on line 42, we have a decorator. And in Python, the values prefixed with an @ symbol are called decorators. This is just a special kind of function that can modify the behavior of another function or class. This decorator tells Flask that when a user navigates to the root URL of the web application, the function index should be executed. Expanding line 43, when a user visits the root URL, it renders an HTML form for username and password inputs, which posts to the login route. And speaking of which, we'll expand line 53. So this route handles the login functionality, gets the username and password from the form data, and constructs a SQL query with these credentials. And then it checks if the credentials are valid. If valid, it returns a welcome message. If invalid, it returns a login failure message. Okay, the SQL injection vulnerability arises because the query string on line 59 is formatted using Python's fstring syntax with the user input directly inserted into the query. This means an attacker can manipulate the username and password input to alter the query's logic. This makes it susceptible to a simple SQL injection query, typically called single quote and comment injection. So the single quote finishes off the username component, and the double dash signifies the beginning of a comment. So everything following the double dash in the line is ignored by the rest of the SQL interpreter. So what does that mean? Well, it means it comments out the rest of the SQL query, effectively removing the password check, allowing unauthorized login as the admin user. And finally, on line 69, if name equals main, this is the standard Python idiom for a script's entry point. Now, note on line 70, this runs the application with the Flask development server. The debug equals true argument enhances our development workflow by providing automatic reloading, detailed error messages, and browser-based debugging. However, it should never be enabled in production for security reasons. Okay, let's run the vulnerable app. So down on the taskbar, I'll select the PowerShell icon to bring up the PowerShell terminal that I have open. In it, I'll type Python vulnerable-webapp.py and press enter and run the application. And it shows that it's running on localhost at port 5000. Okay, now down on the taskbar, I'll bring up a web browser, and in the address bar, I'll type localhost:5000. And that loads the app. Okay, now let's go back to Visual Studio Code for a moment, and I'll bring up the AI-assisted SQL injection Python script. Okay, here we're going to import the OpenAI class from the OpenAI module. Then we initialize the OpenAI client on line 4. Then I'll expand line 7, and this is my message content. Basically, I'm indicating that I have this web application with a login form, and I'd like to test it to make sure that it has no SQL injection vulnerabilities. I provide GPT-4 with some information about the web app, and then I ask for 10 payload entries that I can place in the username field to potentially test for SQL injection. I also give it some hints for output format. Okay, then expanding line 15. So essentially I tell GPT-4 that it's a helpful cybersecurity expert that's a part of my security operations team. And the second part of my message, I indicate my message content. Then on lines 26 and 27, I process the response from GPT-4 and print the results. Okay, so let's run the AI-assisted SQL injection script. So down in terminal, I'll type Python AI-assisted SQL injection.py. And now it provides me with 10 possibilities. So I'm just going to use the first suggestion. Recall earlier when I explained the vulnerability that existed in the login function? So here I have the single quote comment injection potential. Remember in SQL earlier I said that the double dash signifies the beginning of a comment. Well, we have the quote, which finishes off the username component of the query, and then we have the double dash that comments out the rest of the SQL query, effectively removing the password check and allowing me unauthorized login access as the admin user. So let's bring up the browser and we'll try that. So admin, single quote, dash dash, press enter. Okay, with GPT-4's suggestion, we successfully manipulated the username input to alter the query's logic. We effectively broke the password check, and hence we've successfully logged in as the admin user. All right then, with that, we've performed an AI-assisted SQL injection attack. In this demo, we'll use generative AI to detect web application vulnerabilities. Okay, to get started in my demo, I've opened Visual Studio Code with the files that I'm going to use, and we're going to perform two scans. We're going to perform a dynamic scan on a running application, and we're going to perform a static scan. In other words, we're going to get GPT-4 to analyze our code. Okay, so first, let's examine the vulnerability scan dynamic Python script. Okay, so line 1, I'm importing subprocess, and this allows me to spawn processes and connect to their input, output, or error pipes and obtain their return codes in Python. And just hang on to that thought, we'll come back to that. On line 2, I import the OpenAI class from the OpenAI module. On lines 5 and 6, I specify the Python interpreter and the path to the SQLmap.py script that we're going to use. Then on lines 9 and 10, we set up and run SQLmap as a subprocess. Now we're doing this with subprocess because there's no official Python library for SQLmap that we can just simply import and use within a script. We can execute SQLmap as a subprocess within a Python script though, and this allows for a level of automation and integration that can greatly enhance our testing capabilities and efficiency in performing tests like this. Okay, so line 9 is creating a list named command, and that's going to be used to store all the parts of the command that we want to run in the shell. It starts with the Python interpreter, then the SQLmap command, which is essentially the path to the SQLmap.py script, and we're going to clone a GitHub repo shortly for that. After that, we have several arguments that tell SQL map how to behave. For example, -u and the URL. And then forms tells SQL map to test input forms on a given URL. Batch runs SQL map without manual interaction. We don't want manual interaction. We're automating this whole process. And then level 5 and risk 3, these set the level and risk tests performed by SQL map to their highest settings. So this is the most aggressive and thorough testing. Line 10 is where the actual execution of the command begins. The subprocess run function is used to run the command. The command is the list that we just defined. Capture output equals true tells Python to grab the output of the command. Text equals true means the output will be captured as text rather than binary data. And this is helpful because we're going to feed the text information to the GPT-4 model. The result of subprocess.run is stored in a variable called result. Okay, then on line 13, we save the result from standard out to a variable for processing. And this is not strictly necessary, but it's good for further formatting the output data before sending to GPT-4, for example, if we needed to do that. We won't need to do that for this demo, though. Okay, then on line 16, we initialize the OpenAI client. Then on line 19, so I'll expand line 19, is my message content, where basically I'm explaining that I'm demonstrating how to test an app for vulnerabilities. I'm running it on my local private network. I'm specifying that I'm providing it with the raw output from a SQL map scan. And I'm asking it to examine the output and provide me with a report indicating if there are any vulnerabilities detected and so on. I'm also asking for payload examples and the type of vulnerability from the scan. Now, for one web app, this might be overkill. I mean, we could just specify this in ChatGPT, for example. However, let's imagine that we had to test hundreds of web applications. We could automate the entire thing and run it through a loop and have the GPT-4 model provide us with a comprehensive report. Okay, so expanding line 25, this is where we send the data to GPT-4. And for messages, I'm telling GPT-4 that it's a helpful cybersecurity expert who's a member of my security operations team. Then I specify my message content, and that's going to be the content that we just described. And then the output data, which is just the output from the SQL map scan. Then on lines 37 and 38, we're processing the response from GPT-4 and printing out the report. Okay, so next we're going to clone a GitHub repo. And this GitHub repo is for SQL map. So I'm just including that in readme.txt. If I open readme.txt, it explains the GitHub repository and the command that we're going to use. Okay, so now let's go down to the taskbar. I'll bring up my browser where I've navigated to sqlmap.org. So SQLmap is just an open source penetration testing tool that automates the process of detecting and exploiting SQL injection flaws. Recall, I want to automate this entire process. So that's why I also had to import subprocess, because again, there is no official Python library for SQL map that we can just import and use within our script. So scrolling down the page, under download, I'll highlight the git clone command, right click, select copy. Now back over to Visual Studio Code. And in terminal, I'll right click to paste the git clone command in and press enter. Okay, so the SQL map repo has been cloned locally in a subfolder called sqlmap-dev. Okay, so now let's go down to the taskbar. I'll select the PowerShell icon to bring up the PowerShell terminal that I have open, and I've conveniently already specified the Python command, python vulnerable web app.py, press enter and run the app. Okay, and it shows that it's running on localhost at port 5000. Now let's minimize PowerShell. Now back in terminal in Visual Studio Code, I'll type python vulnerability scan dynamic.py and press enter. Okay, so this runs the SQL map scan against our application, and it provides me with some good information, including the fact that it is susceptible to a SQL injection attack. And it provides me with several details on the type of SQL injection attack, payload, and so on. Okay, so now let's do a static scan. So I'll select the vulnerability scan static.py tab, and here again, we're just importing the OpenAI class from the OpenAI module. Now, expanding line 4, here I'm defining a function named load source code and passing it file path. And essentially, I'm just loading the Python source code. On lines 15 and 16 are the file path and the call to load source code with the file path specified. Then we initialize the OpenAI client, and the message that I specify, my message content, is I want to perform a static security analysis on the source code for a web app. And I'm specifying that the following is the raw source code I want to have scanned, and I'd like GPT-4 to examine the source code and give me a report indicating the types of vulnerabilities that it found. Okay, so now expanding line 27, this is where I send GPT-4 my source code. So for messages, again, helpful cybersecurity expert who's a member of my security operations team. I specify my message content, and in a third message, I specify the source code. Okay, and then on lines 39 and 40, I'm processing and printing the response from GPT-4. Okay, so now down in terminal, I'll type Python, vulnerability scan static.py and press enter. And it comes back with an equally impressive report specifying not only the type of vulnerability, but it actually cites the lines of vulnerable code, and it tells me how to address the issue. All right then, well, with that, we've detected web application vulnerabilities using generative AI. In this demo, we perform an AI-assisted hack of cloud services. Okay, to get started in my demo, I've opened two files in Visual Studio Code. I've got aws-group-analysis.py open and aws-group-analysis-local.py open. Now these two scripts are very similar with one major difference. First, aws-group-analysis.py performs an analysis of groups and permissions in an AWS account directly in AWS. Whereas the local version, well, what it does is it actually takes a JSON file and reads the groups and associated permissions from that JSON file. Okay, so in aws-group-analysis, we have a function named getGroupMetadata. Now, this is using Boto3, which is the AWS Python SDK, to interact with AWS services and resources. So I'm going to get group details and the associated policies with a group and construct the group info. Then later on down in the code, I create a JSON file named group-data.json with that same information. In the local version, basically, instead of get group metadata, I have read group data from file. And it's a much simpler function. So it's basically just going to open a JSON file and read the contents of the JSON file. And the analysis will be performed on that JSON data. Okay, now at the bottom of both scripts, we implement a multi-turn conversation. So if I go down to line 29 and expand line 29, referring to lines 38 through 40, we specify that GPT-4 is a master cybersecurity analyst and researcher. Then we provide some content. First, I ask GPT-4 to analyze these results from this AWS IAM group permissions report and highlight any potential security concerns. Then on line 40, I pass the group's data report. Then later on, starting on line 47, I set up a loop so that I can ask follow-up questions of GPT-4. Okay, now that JSON file over in Visual Studio Code Explorer, I'll double-click to open the group-data.json file. And this is what it looks like. So it lists the group name, the group details, and any inline and managed policies. So we've got administrators, we've got developers, and we've got all the permissions associated with both. Okay, well, let's go over to my browser. And now to set this up, first, suppose I'm a hacker that's managed to hack a developer's AWS Cloud Services account. That user account is dev-user3. And at the top right side of console home, I can clearly see that I've logged in as dev-user3. Okay, now I'm going to open Cloud Shell by selecting the Cloud Shell icon in the toolbar. Okay, now I'll open the terminal in a new browser tab by selecting the Open in New Browser tab icon in the Cloud Shell toolbar. And if I do an ls, right now I've got an archive directory and I've got an aws-group-analysis.py script. And that is the exact same script that we just went over. To work with Cloud Shell, you have to understand that it supports both Python 2 and Python 3. And if you're going to use Python 3, then the command that you'll type is Python 3, not Python. And similarly, if you're going to use pip, the Python package manager, then you're going to install packages for Python 3 using the syntax pip3 install and then the name of the module. To run our script, we'll use Python 3, but we also need the OpenAI module. So to install that, I type pip3 install OpenAI and press enter. Now it'll tell me that the requirement's been satisfied because I've already installed the module. In order to run the script and converse with GPT-4, we need to supply our OpenAI key. For that, we create an environment variable, an env, named OpenAI _ API _ key. To do that, I just altered my .bashrc file. So if I cat out .bashrc, note the line, export OpenAI _ API _ key and the key itself. So each time I open an instance of Cloud Shell with this account, I will have this OpenAI _ API key ready to use. Okay, so let's run the analysis. So I'll type Python 3 aws-group-analysis.py, and for groups I'll specify developers space administrators and press enter. Okay, and we get some pretty good insights from the analysis. First, there are overly broad permissions. It indicates here that the developers group has administrator access attached as a managed policy. This is a high privilege policy granting full access to AWS services and resources. Developer groups typically don't require this level of access and can lead to accidental or intentional privilege misuse. As a hacker, I'm logged in as dev-user3. Because of this cloud misconfiguration, I have full access to AWS services and resources under this account. That's contrary to several best practices, including the principle of least privilege. Users should only be given the permissions they need to accomplish their duties. And one other important item to bring up is that it's usually not a good idea to have just one individual as a member of an administrator's group, because from a business continuity perspective, if that individual is unavailable, there may be tasks that require administrator level permissions that may be delayed, which could impact the operations of the environment. And that's not all. We learn of other insights from the analysis. We learn of excessive S3 bucket permissions, excessive listing permissions, no monitoring or logging policies. We learn of problems with identity and access management, and the fact that there's a lack of segregation of duties involved in this account. So overall, there are several issues, several misconfigurations regarding security in this AWS account. All right, well, I want more information about the administrators group, so I'll issue a follow-up question. Can you tell me more about the one user under the administrator group? Okay, and it tells me all about the one user under the administrator group. So it tells me that there's one user that has an attached managed policy named Administrator Access, again, providing full access to AWS services and resources. So now let's type another follow-up question. What about the user dev-user3? Okay, and it comes back and it says that the data doesn't provide specific details about the individual users. However, it does say that dev-user3, as being part of the developers group, has both inline policies and attached managed policies granting extensive permissions. So what this demonstrates very clearly is that this account is definitely not aligned with the principle of least privilege. All right, so let's go back to the console home tab. And remember, I'm signed in as the hacked account dev-user3. Now reduce the terminal, and in console home, I'll select I am. Okay, and that brings up the identity and access management dashboard. In the left nav menu, I'll select users. And now I'll select the check mark beside the user jQuery. And now if I really want to create chaos, then I can just select delete. And to confirm deletion, enter the name in the text input field, and then select delete user. And at that point, chaos would ensue because that would remove the only person that's a member of the administrators group. All right, now let's go back over to Visual Studio Code for a moment. And let's run that same analysis here locally based on that same group data, which I've already downloaded. So to do that, down in terminal, I'll type Python aws-group-analysis-local.py, specify group data.json. So I'm just auto-completing, pressing enter. And it comes back with pretty similar report. Now there is some randomness to it, but this report is very similar to the report that we ran on the live AWS account, because actually the group data.json file contains all the same data that the script running an AWS Cloud Shell will be accessing. All right then. Well, with that, we performed an AI-assisted hack of cloud services. In this demo, we'll use generative AI to identify and mitigate vulnerabilities in a simulated IoT device. Okay, for this demo, I've opened Visual Studio Code and I have two Python scripts open. The first script is going to simulate an IoT device. We'll go over that shortly. The second script is going to perform a vulnerability scan with the Nmap Python module, and then we're going to submit that information to GPT-4 and have it identify whether there are IoT devices potentially present. And if there are, we're going to ask it for some endpoint API recommendations. And if there are vulnerabilities, which there will be, because we're going to program them in with the simulation Python script, we'll ask it to suggest ways that we can address the vulnerabilities. Okay, so let's start with the simulation code. Okay, so now this is a Flask app. So from lines 1 to 3, I'm importing all the modules that I need. I need SQLite 3, I need Flask, and I need date time, because there are timestamps that are going to be used when tracking device usage, kind of like a logging mechanism. Then we have a function on line 6 named init_db, and this will just initialize the database. Then we call the function to initialize the database on line 34. We initialize the Flask app, and the device state we set at its default on line 38 as off. Now, line 41, this is the function that's going to add sensitive information to the IoT device. I'll just expand line 41. So essentially, we're going to open the IoT_device database with SQLite 3, and we're going to insert some sensitive information into the device, including the SSID, the password, serial number of the device, the model, and firmware version. Then we call add_info with the sensitive Wi-Fi and device info. Then we have a log usage function on line 58, and that's just going to provide a logging mechanism which shows the device usage, including a timestamp and its status. Then we have a number of different routes. We have a config route, and essentially what this is going to do is it's just going to return the API endpoints. Quite a vulnerability there. Then we have a route for turning the IoT device on. This is a simulated smart bulb. For turning it off, we have a route to get the status of the device. We have an insecure route to get Wi-Fi information, and that's at /info. Then we have a route to get the device usage information at getDeviceUsage. And then we set up to run the app. And note that it's listening on port 56700. Now, vulnerability scan with follow-up. So essentially lines 1 to 3, I'm importing the modules that I need. Then I instantiate the client object for interacting with OpenAI. And then I define the start chat session function on line 9. And that's going to allow us to not only query GPT-4, but follow up with additional questions. Okay, then we initialize an Nmap scanner object. Then we perform a scan. That's on line 25. And then on line 27, I'm setting up an empty string for the output. Then I iterate through the scan results. Then I print the analysis. And to set up the conversation with GPT-4, I have 3 messages. The first message on line 46 is from the system role, and the content is you are a master cybersecurity analyst and researcher. Then user role on line 47 with the content, analyze these Nmap scan results and identify any open ports that could potentially be from an IoT device. Then we're going to provide it on line 48 with the content that we get from the scan. And that's stored again in a variable called recon_info. Okay, and now the rest of the code essentially is just setting up so that we can have a multi-turn conversation with GPT-4. Okay, so a couple of things we need to do. First, if I go down to the taskbar, I'll bring up PowerShell 7. And what I'm going to do first is I'm going to run the simulated IoT device. Okay, now to do that, I'll type Python sim iotdevice.py and press enter. Okay, and it indicates that it's running on http://127.0.0.1:56700. Okay, so now if we open a browser, I can go to the route 127.0.0.1:56700/status. Okay, and that gives us the status of the device. And remember, by default, I said it was off, so it shows here that it's currently off. Okay, so now let's say that this is the only route that I'm aware of. So at this point, what I'm going to do is I'm going to run the analysis and have GPT-4 indicate whether there is an IoT device, and we know that there is because we're simulating it. Then we're going to ask it if it can recommend some API endpoints in addition to status here. And then we're going to ask for some ways to address the vulnerabilities that are associated with the device. Okay, so now back down to the taskbar, I'll bring up Visual Studio Code, and now we'll run the vulnerability scan, and we'll do that by typing Python vulnerability scan with follow-up.py. All right, so it tells us that port 56700 is open, and we knew that. And it tells us that it's typically used by an IoT device protocol called Multicast Domain Name System. This protocol is typically used for network service discovery and so on. Okay, so it indicates that yes, an IoT device might be using this port, but it does offer a caution that additional analysis is required to confirm that the open port is an active and potentially vulnerable IoT device. So now, let's tell it that we've determined that this API endpoint works, the /status endpoint, and ask it to recommend 5 more endpoints. So I've determined that this API endpoint works, and I provide the endpoint. So recommend 5 more endpoints I can try to interact with the device. Alternatively, we could sit here and try thousands of different words for an endpoint, but let's go with this. So I'll press enter. Okay, so it provides us with 5 recommendations, and we can go with one of these recommendations. For example, let's go with the info recommendation. So I'll place my cursor over the URL, hold down Control, and select my left mouse button. Okay, and that provides me with information regarding the device, but it also provides us with the Wi-Fi SSID as well as password. And we know that this is the case because we programmed it into the simulated IoT device. So now let's tell GPT-4 what we've discovered and see if it can provide us with some good recommendations on how to address these vulnerabilities. So back over to Visual Studio Code. Now we have another follow-up question. This time I'll tell it that the info route listed some very sensitive information, including the SSID and password, and ask it how we could potentially address the vulnerability. I'll type, so the /info endpoint listed some sensitive information, including the SSID and password. How can we address these glaring vulnerabilities with this device? Okay, now I'll press enter. All right, and GPT-4 comes back with some really valuable recommendations. So it tells us to change the default credentials, but we know that this device doesn't have any authentication whatsoever, which is not totally uncommon with some IoT devices. Number 2 is an excellent suggestion. There may be firmware updates where the manufacturer has a new firmware update that will implement an authentication mechanism of some kind. We have another recommendation of network segmentation, then implementing access control lists, encryption. So we should understand that since we're using the HTTP protocol, that the data is not even encrypted, so it can easily be intercepted, right? So it lists that as a potential suggestion. There's the secure setup of APIs and regular security audits, which is what we're doing right now. And it also says to disable unnecessary services. So all in all, we've managed to get GPT-4 to recognize that we have an IoT device that has some serious vulnerabilities. And it's come back and recommended some very valuable ways that we can address these vulnerabilities. Okay, then with that, we've employed generative AI to identify and mitigate vulnerabilities in a simulated IoT device. In this demo, we'll enhance mobile platform security measures. In this demo, we're going to create a password strength education tool using generative AI to bolster mobile platform security. It's generally considered that humans are the weak link in cybersecurity anyway, so anything that we can do to bolster that component of security posture, the better. It's good for so many reasons, including the fact that it raises password security awareness and the need for strong passwords to protect against cyber threats. We use generative AI for tailored advice and engaging educational experiences. Plus, it's scalable and accessible and keeps pace with cybersecurity trends for relevant content. It addresses the growing importance of security on mobile devices, promotes proactive cybersecurity behavior, it's cost-effective, and it also complements the more technical security measures while highlighting the importance of human involvement in cybersecurity. So to get started, I've opened Visual Studio Code and I have a Python script and an index.html template open. We're going to create a little Flask application, and the objective of the application is to create an interactive app where users can ask questions about password security. The app maintains a conversation history with each user, sends this history to GPT-4 for analysis, and displays the ongoing conversation. Okay, let's break down this Flask application code piece by piece. So, first, lines 1 to 3, we're importing the modules that we need, and Flask, of course, is the main framework for building the web application. Render template is used to render HTML templates. Request is used for handling requests, and session is a dictionary-like object that can be used to store information for a specific user from one request to the next. It is a part of Flask's built-in session management. It's typically stored client-side in the user's browser as a cookie. In the code, session is used to store and manage user-specific data like conversation. OpenAI is for interacting with the OpenAI API. And secrets is used to generate cryptographically strong pseudo-random numbers that are suitable for managing secrets like account authentication, tokens, and similar. Next, from lines 6 through 8, the Flask app instance is created. The session configuration is set to not be permanent, and a secret key for the Flask app is set to a random 16-bit hex string, which is used to securely sign the session cookie, which is just security best practice. Next, on line 11, we initialize the OpenAI client. Then starting on line 14, this is the route definition for the main page, and it can handle both GET and POST requests. When the user first visits the page, it initializes a conversation list in the session to keep track of the conversation with GPT-4. That's the conditional statement starting on line 17. This snippet checks if the key conversation exists in the Flask session. If it doesn't, it initializes session conversation as an empty list. Then starting on line 21, if the request is a POST request, that is, when the user submits the form data, it gets the user's input and updates the conversation with GPT-4. On line 26, we call a function to generate a response based on the conversation history, which gets passed to the function as an argument. Next, on line 27, the index.html template is rendered, and it uses the password analysis which was returned with the call in the previous line to the generate password analysis function. Okay, next we have the update conversation function. This function updates the session's conversation history with the user's input. The first line retrieves the current conversation history from the Flask session. The get method is used to retrieve the value associated with the key conversation. If conversation does not exist in the session, it defaults to an empty list. We append a new entry to the conversation list on line 32. This is set to the user input passed to the function. After updating the conversation list, we then save it back to the Flask session. By reassigning the modified conversation list to session conversation, we're making the updated conversation available in subsequent requests. Next, on line 36 is the generate password analysis function itself. It prepares the conversation for GPT-4, sends it to the model, and appends the model's response to the conversation. Next, on line 53, we have the format response function. Now, this function formats the conversation into an HTML list, and it also skips the initial system message because we don't need that in the display. And then finally, on line 66, we have the entry point for the application, and note that it runs the app in debug mode. And of course, we wouldn't do this in a production setting. Okay, now over in Explorer, I just want to quickly explain the directory structure here. So Flask looks for templates in a folder named templates by default, and for static content like images in a folder named static. So that's where I'm storing static images, and the templates are being stored in the templates directory. All right, now the second file that I have open is the index.html template. Now this is basically boilerplate HTML, although I do include Bootstrap, jQuery, and some Ajax libraries to help pretty up the application a little bit. So let's run the app and interact with it. And to do that, down in Terminal, I'll type Python, followed by the name of the application, which is Security Buddy Training App. Okay, so now the app is running. It's running on the local host at port 5000. I'll hover over the hyperlink, press Control, and select the hyperlink. Okay, and now the application comes up in my browser. So here's my Security Buddy application. As it says, enter your password security question and then press Enter or select Ask. First, I'll ask it if I have a secure password. So I'll type, is this a secure and strong password? And I'll enter my password, which is capital P @ 55W0RD. And I'll just press Enter. Now it sends off the request and it's conversing with GPT-4 right now. And it comes back with a message from the AI security advisor, which is GPT-4, and it says, no, the password is not considered secure and strong. Although it does include a mix of letters, numbers, and special characters, it's a common password that hackers often guess, right? So for a number of reasons, it's not a very secure password. So let's revise our password and ask it if the new revised password is secure. And we'll enter some random characters. Should be a pretty secure password. I'll press Enter. And now it comes back and it tells us that, yes, this password is considered secure and strong. It's long, 16 characters, includes a mix of upper and lowercase letters, special characters, and does not contain any common words. And then it finishes up by reminding us to keep our passwords safe and avoid sharing them with others. All right, well, with that, we have enhanced security on mobile platforms using generative AI. In this demo, we participate in an AI-assisted mobile platform hack. All right, for my demo, I've opened two files in Visual Studio Code. I have my script. It's a Python script named AI-assisted hack, and I also have a network device scan. Okay, going over to the network device scan. This is a simulated scan with a myriad of data regarding a specific device. So in the scan report, I have the scan date, the device type, the operating system, so it's an iOS 12.4 device. So that's probably going to be an Apple iPhone. Then there's device information, including the IP address, the device name, the MAC address. There's network information, device configuration information, installed applications, and security and privacy settings that have been enabled. All right, so now what we're going to do with the Python script is we're going to open that network device scan, and we're going to get GPT-4 to provide us with an analysis and some suggestions on how we can address the vulnerabilities. And we'll ask it for some CVE numbers that will support research into vulnerabilities and exploits related to such a device. Okay, so lines 1 and 2, I import the modules that I need for this particular script. OpenAI is the OpenAI client. On line 5, we initialize the client. Then we get the device scan starting on line 8. Then on line 12, this is where we start the chat session. And here on lines 13 and 14, we're going to check if there's a new user message, and if so, we're going to append it to previous messages so that we can maintain the entire conversation for subsequent queries. On line 22, we return the response and the previous messages. On line 24, I define a print analysis function where I'm going to basically print the content of the analysis. And then starting on line 29, this is where we implement the multi-turn conversation. Line 37 starts the list of messages. So we have the system role, then we have the user content, which is analyze network device scan and highlight any potential vulnerabilities you find. And of course, we feed it the device scan report itself. On line 43, we call start chat session, and we provide it with the previous messages list, and it returns the analysis as well as previous messages, again, to continue to keep the conversation, and then we print the analysis on line 44. Line 46 starts the section of the code where we implement the multi-turn conversation, which will allow us to ask follow-up questions until we're satisfied, at which case we type exit, and then we break out of the program normally. All right, let's see what we get. So down in terminal, to run the script, first I'll type Python. Now I also have to specify the AI-assisted hack Python script, and for the second argument, I specify network device scan.txt. That's the device scan that we explored earlier. I'll press enter to run the analysis. All right, and GPT-4 comes back and it highlights quite a few potential security vulnerabilities. For example, the outdated operating system, Bluetooth and location services have been enabled, VPNs not configured, we've got outdated applications, security protocols, for example, using WPA2 network security, and then it provides considerations for mitigating the threats. So this accomplishes two things for this demo. Number one, it highlights the AI-enhanced countermeasures that can take place. So for example, as an ethical hacker, I'm trying to uncover these vulnerabilities so that we can address them, and GPT-4 has helped us with that by providing several considerations for mitigating the threats that were found. While at the same time, as a hacker, I'm attempting to uncover the vulnerabilities so that if I was a malicious attacker, I would know which vulnerabilities existed and therefore be able to exploit them. So in this case, I'd have a follow-up question. So I'd ask for some CVE numbers so that I can further research the exploits and choose which ones that I want to pursue. So where it says your follow-up question, I'll ask, could you specify some CVE numbers so that I can research these vulnerabilities in more detail? Pressing enter to submit my query. Okay, and so GPT-4 comes back with 3 specific CVE numbers. So on one side, if I'm an ethical hacker, I know the vulnerabilities that exist, I can research them, and I can provide some recommendations for how to address them. As a malicious hacker, at this point, I would have these CVE numbers, and I know the vulnerabilities, so I can pick and choose which one that I want to pursue. All right then, with that, we've performed an AI-assisted mobile platform hack. In this demo, we'll use generative AI to identify and help patch vulnerabilities in a mobile app. In this scenario, we're considering a type of vulnerability that can be found in some mobile applications, namely insecure communication. This type of vulnerability occurs when an app communicates with a server or other network services or over an unsecured connection, potentially allowing attackers to intercept sensitive data. We'll look at this code shortly, but essentially what happens is it's going to use HTTP for communication instead of HTTPS, which means that the data is not encrypted in transit and therefore can be intercepted. Of course, this is a simplified example. In real applications, network operations must always be handled with proper asynchronous methods or libraries. For example, in Android development, properly handling network operations asynchronously is crucial to ensuring a responsive UI and to comply with Android's requirement that network operations not be performed on the main UI thread. We also know it's best practice to use HTTPS and proper SSL TLS on mobile platforms, and indeed on any platform for that matter. Okay, so in Visual Studio Code, I have a Python script open, and I have 2 source code files. One's called mainActivity.java, and the other is activity_main.xml. So let's have a quick look at the source code. First, activity main. For this pseudocode, we add edit text fields for user input. It's a UI element that allows users to enter and modify text. And button is another UI element that users can tap on or click to perform an action. In this case, the XML layout includes a button to send the data. Okay, now the Java code. So this Java code snippet is a basic example of an Android activity called main activity that demonstrates sending data to a server using HTTP URL connection. So let's just briefly explore the source code. So starting on line 1, main activity extends app compat activity class. It initializes an edit text element username field and a button called send button by finding them in the layout using their IDs. The code sets an on-click listener on the send button. So what happens is when the button is clicked, it retrieves the text from the username field and calls the send data method with the text as an argument. A new thread is created to handle the network operation, ensuring the network request does not block the main thread, that's the UI thread. Inside the thread, it attempts to establish an HTTP connection to a hard-coded URL. That's http://brocadero.com/API/send. The connection uses a post method, and the data username is sent in the request body. HTTP URL connection does support HTTPS, but it's up to the developer to use HTTPS URLs. Using HTTP is, again, insecure because it transmits data in plain text over HTTP. All right, so that's the main activity.java file. Now, the mobile app code scan Python script is going to accept a directory path as an argument. Let's just go over the code briefly. Okay, so lines 1 to 3, I import the modules that I need. Then on line 6, I initialize the OpenAI client. Starting on line 9, I define a function called readscan data and pass it the directory path. And that will iterate over all the files in the directory path that's specified. And it will store all the code in a variable called all_files_content. Starting on line 18, I define the start chat session function, passing it previous messages and the new user message so that we can have that entire conversation available for subsequent queries. Then we return the response and the previous messages. Then on line 30, I define the print analysis function, passing it the response. On line 35, I start implementing the multi-turn conversation. And notice on lines 40 and 41, essentially I'm setting up the source code directory and reading that as an argument that's passed in when I run the script. Line 43 is the list of messages. So we have the system role, and the system is going to be a master cybersecurity analyst and researcher. Then we have the user role, and the content there is analyze the following source code and report any potential vulnerabilities. And we also pass it the source code content. Then we perform the analysis by calling the start chat session function and pass it previous messages. Then starting on line 53, we implement the loop, which will allow us to ask follow-up questions until we're satisfied. And in that case, we type exit and exit the program. Okay, so let's run the program and let's see what we get. So down in terminal, I'll type Python, the name of the script, which is mobile app code scan.py. And I'll specify the source directory, which is right off the demo directory that I'm in right now. So I would start typing source src and just autocomplete. Okay, so I'll press enter to run the scan. Okay, and GPT-4 comes back. And first, it gives us a summary of what the code seems to be doing. So it says it seems to be capturing user input and sending it to a server. It says, while the code is straightforward, there are several security implications that must be addressed. Number one, there's no input validation. So it tells us that the code currently does not validate the input received from the user, which makes it vulnerable to injection attacks. Then point number 2, the use of HTTP instead of HTTPS, which is what we discussed earlier. There's another issue with the hard-coded URL. There's potential issues with exception handling and with thread usage. And data security, it indicates that the app doesn't seem to encrypt the data before sending it. So there's more than just the basic HTTP issue. Now, for a follow-up question, I'm going to ask GPT-4 how I can refactor the Java code to make it more secure. And let's see what it comes back with for recommendations. So I'll type, how can I refactor the Java code to make it more secure? And press enter. Okay, so let's see what GPT-4 came back with. So it indicates, here's how you can refactor the Java code to make it more secure. And it actually provides the Java code refactored for us. So it replaces the use of a background thread with an async task, which is more appropriate for tasks that execute on a background thread. It uses HTTPS for secure transfer. It adds code to encode the data being sent in base 64, or we could use hash encryption. It separates the task of writing output to the data stream by using data output stream, and it closes the output stream after data has been written to free up system resources. So with this simple little 60-line Python script, we not only had GPT-4 identify vulnerabilities, it also provided refactored code and recommendations for making the entire Java code more secure. All right then, with that, we've used generative AI to identify and patch vulnerabilities in a mobile app. In this demo, we'll use generative AI to help cover tracks. Okay, to start my demo, I'm on my Kali Linux box. Now, Kali comes with SSH pre-installed, so that's the client and server. Later on, we'll use a secure shell client on a Windows 11 machine to remote into this Kali Linux machine. Now, if the secure shell service isn't started on the Kali Linux box, you can type sudo systemctl status instead of start SSH. So that's sudo systemctl status SSH. And the response clearly shows that secure shell server is active and running. Okay, with that established, let's go over to my Windows 11 machine where I have Visual Studio Code open. I have a Python script named covertracks.py opened, and I have a text file named device-info.txt open. Now this is just the device information for the Kali box, and I'm going to send this to GPT-4 later on. I just got this information by typing the command that's listed on the first line, cat/etc/os-release. Okay, let's go over to this script. Starting on line 1, we're importing the modules we need. Then on line 5, we initialize the OpenAI client. And recall, it's going to be looking for an environment variable named OpenAI_API_key. So you should already have that environment variable set up on your machine. Then on line 8, I define the read device info function that's going to read the device info from a file on the local file system, and that's the device-info.txt file that I mentioned earlier. Starting on line 12, this is where we start the chat session with GPT-4. And here we've got typical parameters, and the model we're specifying is GPT-4. And we're returning response and previous messages because we want to maintain both in order to implement the multi-turn conversation. Now on line 24, the print analysis function essentially just prints the response that we get from GPT-4. Then starting on line 29, this is where we implement the multi-turn conversation. And on line 31, when we invoke the script, if we fail to include both the script and the device info arguments, then we'll print a reminder message to the user and then exit. Okay, then on line 35, we get the device info from the file on the local file system. And now the initial prompt. This is important. So here I'm specifying, how can I rotate and completely clear out all systemd journal logs, including the most recent entries on my Debian-based Linux system? And the reason that I want to do this is because we're going to secure shell, or SSH, into the Kali Linux system, and we want to cover our tracks. We don't want there to be a record of us having secure shelled into the machine. So we're going to clear out the systemd journal logs, and we're not going to delete them. Yes, we can force a physical deletion from the file system, but most intrusion detection systems with file integrity monitoring would pick that up immediately. Okay, then starting on line 40, we initialize the previous messages list by telling GPT-4 that it's a master cybersecurity analyst and researcher. Then we pass the initial prompt and the device info. Then on line 46, we make the call to start chat session. We pass the previous messages. Then we print the analysis. We set up the multi-turn conversation on line 50, and this will allow whoever's using the script to provide follow-up questions until they're satisfied, and then they can type exit and exit the program. Okay, now down on my taskbar, I'll select the terminal icon to bring the terminal up. I have PowerShell 7 open with 2 tabs. Now on the first tab, I'm going to SSH into the Kali box. And I do that by typing SSH Kali, that's the user, @ and the IP address for my Kali Linux machine is 192.168.100.130. Pressing enter, I'll specify the password. And success, we've SSH'd into the Kali Linux machine. Okay, now over on the second tab, I'll run the cover tracks Python script. So I'll start typing Python. Now I'll right arrow key to autocomplete because I've already issued this command before, and it's in the command line history for PowerShell. But essentially, you just type Python, the name of the script, and the deviceinfo.txt file on the local file system, then press enter. Okay, and it comes back with everything that we need. So it tells us that we need to open the terminal, use the command sudo journalctl -rotate, and then sudo journalctl -vacuum-time equals 1 second. And this will delete all log files older than 1 second. And the reason why we have to rotate is because we're going to force log rotation. Otherwise, the active log would still exist, so it would show the SSH entries in the log. Okay, so let's go back over to the Kali tab. First, we'll use journalctl to see if there are any SSH entries in the journal log. And for that, I'll type sudo journalctl-u ssh, enter my Kali password. And lo and behold, there are several entries related to SSH. Okay, so we want to cover our tracks. We want to remove these. So first what we'll do is we'll rotate the journal logs. So for that, I'll type sudo journalctl-rotate, and now we'll eliminate everything in the logs older than 1 second. Sudo journalctl-vacuum-time equals 1s for 1 second. Press enter. All right, and it responds by telling us that there are archived journals that were deleted. Now let's do that same journalctl command with the -u option and specify SSH and success. So there are no entries any longer in the journal logs. Now let's say at this point we want to escalate privileges. Well, this is why we have the multi-turn conversation, because now I'm going to ask GPT-4 if less is a SUID binary that we can exploit for privilege escalation. So let's go back over to the tab running the Python script, scroll down to the bottom where it says your follow-up question. I'll type on the same system is less SUID binary that can be exploited for privilege escalation. Okay, and it comes back with information indicating that it's not very likely that less is actually an SUID binary that's set up so that we can exploit it on the system. It provides us with some useful information, including a command that we can use to confirm the permissions for the less utility. Okay, so you know what that means. Let's go back over to the Kali machine, and this time I'll type ls-l backtick which less backtick and press enter. Okay, and according to the instructions that we were provided by GPT-4, it doesn't appear that the S bit is set. Okay, now with the exploit, the SUID binary exploit, it typically involves a situation where, for example, the less command has been mistakenly given SUID permissions, and that means that it can be executed with root privileges. We can exploit this to launch a shell if it's set up in such a way. So we'll then have a shell with root privileges. Okay, so in spite of what GPT-4 told us, let's try it. So I'll type sudo less/etc/passwd. Okay, and less brings up the passwd file. Now I'll just type !sh, and this may get us a shell if this is an SUID binary. And it appears to have worked. Now if I type who am I, the response is root. So we've also successfully elevated to root privileges on this machine. Okay, well with that, we've successfully used generative AI to help cover tracks. In this demo, we'll use generative AI to identify signs of track covering activities. To start my demo, I'm on my Windows 11 machine, and I've got Visual Studio Code open with a Python script named audit-access-logs.py, and I also have another file, access.log, open. Now, down on the toolbar, I'll select the terminal icon to bring up PowerShell. I have PowerShell open with 2 tabs. On the first tab, I've SSH'd into a remote Kali Linux machine. Kali comes with Apache 2 web server pre-installed, and accordingly, it stores Apache 2 logs on the local file system. Okay, so first I'll just elevate privileges to root privileges by typing sudo -i Kali password. Now cd to var log apache2. Now if I do an ls, I have a couple of log files. We're interested in access.log. Now if I do an ll on access.log, it's a pretty big file. Now let's do a line count. For that, I'll type wc-l access.log. Okay, so there's approximately 2.3 million lines in the access.log file. So this is huge. And it's hard for humans to sift through all the access.log entries line by line. Each line in the log represents a single request made to the server, and each line has a number of different columns that provide valuable data for analyzing web traffic, troubleshooting issues, and detecting malicious traffic. You see, sophisticated hackers will often try to blend their malicious activities with legitimate traffic in an attempt to avoid detection. They may perform common operations like hitting standard web pages, using different user agents, distributing their requests over time, and even from various IP addresses. Therefore, it's important to have robust security analytics, tools, and skills in place that can detect and interpret suspicious activities, even if they are masked as legitimate requests. And that's exactly what we'll do using GPT-4 in this demo. Okay, back over to Visual Studio Code. So for my Python script, starting on line 1, we import the modules we need, then we initialize the OpenAI client, then we define a function, read access logs, and this is going to read the access logs from a file on the local file system. On line 12, we start the chat session, and this is going to be a multi-turn conversation, so if we want to ask follow-up questions, we'll be able to do so. Notice the model on line 17 is GPT-4. Then we print the analysis using the print analysis function, that's on line 24. Then starting on line 29, we implement the multi-turn conversation. Now the important part that I'd like to highlight here starts on line 36. This is the initial prompt. So I'm telling GPT-4 that here's some access log data from an Apache 2 log. Please review this and generate a report of any potential entries in the log that may indicate hackers trying to infiltrate our network. For the report, please give me a formatted report with headings and make it look professional. So that's pretty self-explanatory. Okay, so now let's explore the access log. All right, now this access log doesn't have 2.3 million rows, but these lines alone will give us an accurate understanding of how GPT-4 can sift through multiple lines and detect some potentially malicious activity. Okay, just quickly going over the columns. First we have the client IP address, then we have the remote log name, and this is typically represented by a hyphen because in most configurations it's rarely used. Then we have the authenticated user. If no user is authenticated, then it's represented by a hyphen. Then we have the date and time of the request. Then we have the request line from the client, and this is the actual request line from the client, including the method, get or post, for example, the resource requested, and the protocol version. It includes a status code, the size of the response, the referrer, which is the URL of the referring document if there is one, otherwise it's represented by a hyphen. Then there's the user agent, and the user agent string of the client identifies the client's browser, the operating system, and some other details. So I know there's at least a couple of entries here that are suspicious. For example, look at line 13. Get admin panel hidden settings. And then just below that, on lines 17 and 18, we have two instances of get confidential data-export.php. Now, even though these requests resulted in 404 not found and 403 forbidden responses, it does indicate that someone may be probing for sensitive or hidden directories which might contain confidential data. Now imagine we had the 2.3 million lines from the access.log file that we saw over on the web server. It would be virtually impossible for us to go through the entries line by line to find potentially suspicious activity interspersed amongst the 2.3 million requests. Let's run the audit access log script. So we'll go back to terminal. I'll select the second tab in PowerShell. And now to run the script, I'll type Python, I'll right arrow to autocomplete. But basically, I would just start typing audit access logs and autocomplete, and then start typing access.log and autocomplete that. So Python audit-access-logs.py and access.log. pressing enter. And GPT-4 comes back with our cybersecurity report and provides us a comprehensive analysis of potentially malicious activities. So the first entry of interest tells us that the logs indicate a delete method from a specific IP address on an API and a return to 404 status indicating the requested resource doesn't exist. It also tells us that the user agent is CORL, and this is a command line tool used from the terminal. It possibly indicates a hacking attempt. Then the second interesting entry shows a GET request to access the WordPress login page. Then, as we noticed earlier, the third entry has a GET request for admin panel hidden settings.php, and although again it returned a 404 status code, it could suggest that the user was trying to access potentially sensitive or restricted information. Then, listed as number 4, GPT-4 recognized that there are both a GET and a POST request within a very short interval to the WordPress login page. And this is an indicator of potential password brute force attack. And listed as number 5, this entry unfortunately was cut off due to my limitation for max tokens. I had it set at 500. If I wanted, I could expand it to 1,000 tokens and this report would complete. Nevertheless, this is good. And this entry actually indicates the entry that we noticed earlier where there's a GET request for confidential/data-export.php. And this again could indicate that someone is probing for sensitive or hidden data. So overall, GPT-4 was able to sift through the Aaccess log and point out some interesting entries. At this point, it's important that we investigate the logs further. This could involve correlating these requests with other logs for suspicious activities, reviewing web app security settings and access controls, and monitoring for repeated or similar access patterns from these IPs or user agents, and any other tasks as required. It's important to keep in mind that logs often provide initial clues, and continuous monitoring and analysis are key to maintaining network security. With that, we've successfully used generative AI to identify signs of track covering activities.